YF-22 is making a strong comeback, now equipped with the world's most advanced technology. After several years of being overlooked, this aircraft is finally getting upgraded and gearing up to dominate the skies. Ironically, this sudden resurgence comes at a time the USAF is debating whether to retire or upgrade the F-22 Raptor, the aircraft that was selected over the YF-23. This unexpected development has sparked a wave of curiosity and has raised key questions, such as, is the YF-23 being redeveloped as the F-8X? Why was this airfighter initially rejected by the USAF? Join us as we unveil something truly magnificent, the new YF-23 that has shocked Russia and China. The aircraft that was once rejected by the Air Force has now truly become the most sought after. While this narrative well describes the situation with the YF-23, it leaves out some of the key details of how the USAF perceived the aircraft as not sophisticated enough for its affairs. Let's get into that, traveling back in time to the 1980s during the Cold War, when the United States Air Force recognized their immediate need for a new and technologically advanced fighter that would be sophisticated enough to replace the F-15 and be agile enough to counter the Soviets' formidable fighters, the Su-27 and MiG-29. When the USAF put the words out, renowned aviation companies immediately jumped at the offer. However, only Northrop and Lockheed were selected to create prototypes. They were allowed to partner with other companies of their choice. For instance, Northrop teamed up with McDonnell Douglas to develop the YF-23, while Lockheed Martin partnered with Boeing and General Dynamics to design the YF-22. The prototypes from these companies were unique. The YF-23 was designed to be faster and stealthier, but it was not agile. After a series of tests, the USAF came to a very difficult decision, which led to the selection of the YF-22, the Raptor dominating the skies today. The YF-23, on the other hand, were stored while different groups thought about using them for more research. But none of those plans moved forward. In 2004, Northrop Grumman used the second YF-23 as a display for a regional bomber project, but the project was canceled because bombers with a longer range were needed. Both prototypes were eventually displayed in museums. Well, its fate is about to change. While the United States was ready to unleash the power of advanced technology on its enemies, the reason for the haste development of this aircraft suddenly crumbled along with the Soviet Union collapsing. This was quite unexpected. Well, it reduced the United States' worries. Both the F-22 and F-23 would have been top fighters in the early 21st century. The question was which one the Department of Defense would fund, and we all know the answer to that. Each plane had strengths. The YF-23 had a unique look with a flat pancake-like body and blended wings. Its diamond-shaped wings helped reduce air drag at high speeds. Only 2 prototypes of the YF-23 were ever built. The first prototype was nicknamed the Black Widow II by the Northrop Grumman team because of its sleek black paint. The aircraft was equipped with a powerful propulsion system, the Pratt & Whitney YF-119 PW100 engines, that gave the fighter the ability to supercruise at Mach 1.43, or about 1,088 miles per hour, which meant that it could maintain that airspeed without the use of its afterburners. Also called DP-117K, this prototype was designed to show Northrop's plan for a next-generation fighter. It needed to be fast, stealthy, and easy to maintain. The plane had a sleek, unusual look with diamond-shaped wings and a body built to cut through the air at high speeds. It had unique V-shaped tails and a cockpit placed high for better pilot visibility. The sharp nose design helped with maneuvering, and its landing gear included 3 wheels. A large weapons bay was placed underneath for storing missiles. It was designed to be less stable for better performance, controlled by a computer through fly-by-wire technology. To roll, it raised flaps on one side and lowered them on the other. The V-shaped tail fins, angled at 50 degrees, controlled pitch and yaw by rotating in different ways. Test pilot Paul Metz said, "The YF-23 handled better at high angles of attack than older planes, reaching up to 60 degrees AOA. For braking, both wing flaps went down and ailerons went up. To save money, some parts came from other planes like the F-15 and F/A-18. The second YF-23 prototype was called the Gray Ghost because of its paint. It had General Electric YF-120 engines, letting it reach Mach 1.6, which is over 1,200 miles per hour in supercruise. Its top speed was around Mach 2. In comparison, the YF-22 hit Mach 1.58. The YF-23 had a longer range of 2,796 miles and could fly up to 65,000 feet, while the YF-22 had a range of 2,000 miles and a ceiling of 50,000 feet. The YF-23 was fast, stealthy, and hard to detect by radar. But Lockheed Martin's YF-22 was better marketed. It was armed with a fixed 20mm M61 Vulcan, while the internal bay was capable of housing 4 AIM-9 short-range missiles. It took the Air Force several years of tests before they could come to a conclusion. This proved how difficult their decision was. Now, this stirred up a lot of controversial questions. If the YF-23 was believed to be better than the YF-22 in terms of performance, why then do we have the Raptor soaring the skies? According to Dave Majumdar, politics and bureaucracy played quite a huge role in the selection of the F-22. The Pentagon was already frustrated with Northrop and McDonnell Douglas after issues with the B-2 and A-12 projects, and this frustration worked in favor of Lockheed's YF-22. The Navy, however, disliked the F-23 for unique reasons, hoping to adapt the F-22 for its needs. The Air Force preferred the F-22's superior maneuverability, which gave it an edge in most combat situations. If the competition hadn't happened during the Soviet Union's collapse, the YF-23 might have had a better chance. Its advanced features could have attracted more investment, and building both planes could have helped the defense industry. Ultimately, choosing Lockheed's design contributed to the merger of Boeing and McDonnell Douglas. Nearly 25 years after losing the ATF bid, this powerful aircraft was almost brought back when an American ally needed a strong fighter. Japan had long been interested in stealth jets and tried to get the Raptor from the US. Facing threats from North Korea and China, Japan wanted to strengthen its air force. However, Congress refused to sell the F-22 for 2 reasons: to keep its classified technology safe and to maintain the power balance in the Indo-Pacific. At the time, China wasn't seen as a major threat, and the US was focused on the war on terror. The Japanese Air Force decided to create its own stealth fighter. Tokyo later joined the F-35 Joint Fighter Program and now uses both F-35A and F-35B jets. After much study and building models, Japan's Mitsubishi X-2 Shinshin test aircraft flew as a technology demonstrator in 2016. However, Japan is still looking for a new stealth plane for the future. In 2018, Tokyo's search for partners in its FX stealth fighter program got an eager response from Northrop Grumman. While there was talk of reviving the YF-23, Sebastian Roblin noted that Northrop would likely offer key design elements, like parts of the airframe and engine, that could be combined with Japan's cutting-edge tech. The YF-23, though impressive, is 30 years old, and its radar-absorbing materials and avionics are outdated. Still, Japan might prefer upgrading a proven design rather than starting from scratch, as Roblin suggested. In late 2023, Japan's foreign and defense ministers signed an important defense agreement with Britain and Italy to work together on developing a 6th-generation fighter jet. After the signing, Japan's defense minister, Kihara Minoru, expressed his belief that this partnership combines the best technologies from Japan, the UK, and Italy to strengthen security during a challenging time, the most complex since the Second World War. The aim is to have a 6th-generation fighter ready by 2035, with Japan likely developing the airframe while European partners integrate advanced technologies. There's even a chance this airframe will be based on the YF-23. London expects the project to use cutting-edge technologies, making the fighter one of the most advanced, adaptable, and connected in the world. It will be a supersonic stealth jet with advanced sensors and next-gen artificial intelligence, capable of flying without a pilot and equipped with hypersonic weapons. Its powerful radar will provide 10,000 times more data than current systems, giving it a significant edge in battle. The YF-23 was a remarkable aircraft designed for stealth and supercruise. Even though it lost to the F-22, it was ahead of its time because the U.S. Air Force envisioned what air combat would be like in the 21st century when it was built. Many parts of the YF-23 are still classified, and its technology could be used in future stealth fighters and other aircraft. Although it finished second, the YF-23 was still a technological success. While there are rumors of the YF-23 being modified to be the next generation FA-XX, the USAF has not confirmed anything, and it still remains a theory, quite an interesting one at that. What would the modified YF-23 look like as a sixth-generation aircraft? If there is an iota of truth to this theory, this new aircraft would replace the F-14D Super Tomcat as the U.S. Navy's long-range air superiority fighter. Northrop Grumman engineers should lead the development and would be working closely with Saab to create the new fighter. Including Saab is important because of their success with the Gripen, which is designed for easy maintenance and upgrades. Production should happen in one location to ensure easy oversight, rather than being spread across the country for political reasons. The main goal would be to use many existing top-quality systems and proven technology to speed up the development of the A model. Technology from the latest versions of the F-15K/SA, including two-seat cockpits and parts from the Super Hornet, should be considered. An infrared search and track system is essential, with important sensors facing the rear and sides. For ground attack missions, the aircraft would use a modified targeting pod in one half of the front weapons bay. The A model would not use radar-absorbent paint, which has been noticed to complicate maintenance, but later models or special United States Air Force versions could have this feature. The B model should include a fully developed variable cycle engine, and all designs should allow for the addition of conformal fuel tanks. To ensure the aircraft can be easily maintained, it must be able to operate in rough field conditions like the A-10 Warthog and at various locations, where maintenance support will come from two trucks or a C-130. Major changes to the original YF-23 design would involve increasing the space between the engines to create a larger weapons bay. There might also be the addition of canards or leading-edge extensions for better performance during slower flights. The aircraft could have a blown wing or a large air brake to help reduce landing speeds. While major modifications and technological upgrades would be done to the aircraft, it's still not a fact that it would surpass the ability of the F-22 in terms of capability or technological advancement. And if you're wondering why, well, here it is. Over the years, the F-22 has received numerous upgrades, and the USAF has spent not millions but billions on keeping this aircraft technologically upgraded to take on threats, especially since the country's sixth-generation aircraft is still being developed. Recently, the United States Air Force recently awarded RTX a contract of $1 billion to upgrade its sensors for new ones that are categorized as Group B hardware, together with slates and support equipment. The work is scheduled to take place in McKinney, Texas, and is expected to be finished by May 8, 2029, according to the Department of Defense contract statement. The aviationist recently reported that the Air Force is testing new sensors on the F-22 to help extend its service life, which will also be used for the NGAD systems. The report also mentioned Brigadier General Jason D. Voorhees, the Program Executive Officer for Fighter and Advanced Aircraft, who stated they aim to implement these sensors more quickly. The F-22 team has completed 6 flight tests to show the advanced sensors. The F-22 team is working hard to modernize with advanced sensors, better connectivity, weapons, and other features. We're making good progress, which will allow for a fast rollout soon, he said. This will be achieved through a middle-tier acquisition program. Some of the sensors mentioned in the contract could be the stealthy pods used on the F-22. Air and Space Forces previously quoted officials who confirmed that these pods contain IRST, or infrared search and track, sensors. The development of a new IRST sensor for the Raptor was also noted in the service's 2025 budget request, although it didn't specify that the sensor would be in a pod. This effort is part of an F-22 upgrade plan that aims for $7.8 billion in investments before 2030, including $3.1 billion for research and development and $4.7 billion for purchasing new equipment. The development is a surprising change from earlier USAF plans to retire older F-22 airframes, which they had asked Congress to approve. This group includes 32 Block 20 units from a total fleet of 186. Meanwhile, the Air Force is focusing on upgrading the remaining 154 aircraft with exciting new features, such as advanced cryptography, a more flexible open architecture, new weapons, and an improved threat warning receiver, in addition to the IRST sensors. The Aviationist has also reported that the F-22 would be equipped with new fuel tanks. This fuel tank, called the low-drag tank in pylon, was designed to be stealthier and more efficient than the current 600-gallon tanks. The LDTP aims to allow the F-22 to fly supersonic while carrying external tanks and to extend its range. The pylons come with smart rack pneumatic technology for better control during ejection. In its fiscal year 2023 budget request, the United States Air Force stated that the F-22 LDTPs have advanced designs that improve range and endurance while ensuring the aircraft remains effective and safe, which are essential for maintaining air superiority. The introduction of new weapons systems is taking place. The F-22 has typically carried AIM-9 Sidewinder and AIM-120 AMRAAM air-to-air missiles. However, the U.S. Air Force is now adding the AIM-260 Joint Air-to-Surface Standoff Missile, or JASSM-XR, which is a long-range, precision-guided weapon that can hit targets up to 500 miles away. This longer range greatly enhances the F-22's ability to attack targets from a safe distance, lowering the risk to both the aircraft and the pilot. In addition to new missiles, the F-22 is getting upgrades to its targeting and attack features. The new advanced targeting, forward-looking infrared sensor system gives the aircraft better night vision and target identification skills. This upgraded sensor technology helps the F-22 to engage targets more effectively in low-light situations and bad weather. The F-22 is not meant to operate alone in modern warfare. It is built to work together with other aircraft, ground forces, and intelligence resources. The U.S. Air Force is upgrading the F-22's networking abilities to improve how it shares data and communicates with other systems. This better connectivity allows for improved coordination and tactical decision-making, making the F-22 more effective in a connected environment. These upgrades and enhancements aim, in part, to address concerns about the F-22's competitiveness against China's J-25th generation fighter. The war zone also reported that the F-22 Raptor is acting as a technology incubator for the Air Force's next-generation air dominance program, which will be a sixth-generation system featuring a manned fighter supported by unmanned aerial systems serving as loyal wingmen. The 2025 budget request outlines several exciting upgrades, including a Mode 5 identification friend or foe system, Link 16 communications, and a multifunction information distribution system, Joint Tactical Radio System. It also includes a new operational flight program, advanced radar electronic protection, and a modernized embedded GPS inertial navigation system. Brig General Voorhis highlighted the GRACE, which means Government Reference Architecture Compute Environment Software, which would enable the installation of non-traditional F-22 software, enhancing processing power and pilot interfaces. Additionally, a new helmet is being tested as part of the next-generation fixed-wing helmet program to replace the outdated 40-year-old HGU-55P headgear. This modern helmet will support helmet-mounted devices that provide vital flight and weapon aiming information, making pilots' jobs easier. The F-22's role as a testbed for new systems could extend its service as the Air Force's air superiority fighter until the NGAD is operational in the 2030s. Despite being developed during Ronald Reagan's presidency, when Donald Trump was just a struggling businessman, the F-22 remains a highly capable aircraft. With the recent upgrades, it is likely to be able to counter any threats from the Air Force's near-peer adversaries. With this series of upgrades, comparing the capabilities of the F-22 and the proposed YF-23 would be hard. However, if the theory relating to the FAXX is true, these aircraft would only help to boost the United States Air Force's superiority, making other technologically advanced countries tremble in fear. If it were just a mere rumor, the United States keeps advancing in the development of its NGAD program, and with the help of the F-22, the skies would still be dominated with an aircraft that's capable of taking on modern threats. Either way, it's a win-win situation. China has deployed a powerful weapon into the skies, and even the United States' most formidable ships are not safe. Recently, the growing threats from unmanned aerial vehicles have increased at an alarming rate, and now the United States has finally done something about it. To defend itself against the threats that these aircraft pose, the U.S. has equipped its ships with the deadliest weapons in the world. What are the capabilities of these weapons? Are they formidable enough to protect these aircraft carriers from the growing aerial threats? Join us as we explore the features of some of the deadliest weapons that U.S. Navy ships have been equipped with. The United States Navy is renowned for being the largest and most powerful naval force in the world. With over 90,000 active personnel and around 484 warships, the U.S. Navy plays a crucial role in America's military power and national defense. A vital part of the USN's strength is its fleet of 11 nuclear-powered aircraft carriers, including the advanced Gerald R. Ford class and the Nimitz class. These carriers function as mobile air bases, offering exceptional versatility and combat capabilities to deploy air forces anywhere in the world. Each carrier is supported by a strike group of destroyers, cruisers, and submarines, forming a strong maritime force. The United States Navy's surface fleet includes approximately 70 Arleigh Burke-class destroyers and 22 Ticonderoga-class cruisers, both equipped with the Aegis combat system. This advanced system provides excellent air defense, anti-submarine warfare, and ballistic missile defense with sophisticated radar and missile technology. Additionally, the littoral combat ships add flexibility and speed, especially in coastal regions. Another important part of the U.S. Navy is its submarine fleet, which includes both fast-attack submarines and ballistic missile submarines. The Virginia-class SSNs are designed for stealth, reconnaissance, and striking capabilities, while the Ohio-class SSBNs play a crucial role in the U.S. nuclear deterrence strategy. Recently, these warships have been under serious threats from advanced technology like drones and other stealth unmanned aircraft. On October 4, the USS Gerald R. Ford, the newest United States aircraft carrier, set sail for its first deployment amid increasing tensions in the Pacific and uncertainty about the future role of such large ships in warfare. Standing over 9 stories tall and weighing 97,000 tons, 32,000 tons more than the largest Second World War battleships, the Ford is impressive in size. However, it is also fast, powered by advanced A-1B nuclear reactors that give it about 300 megawatts of power, making it nearly 3 times more powerful than current supercarriers. Despite its strength, new anti-ship missiles from China, capable of speeds above Mach 5, pose a significant threat to the Ford and the entire Navy fleet in the Pacific. These missiles could potentially destroy the most advanced ships, similar to how Japan used new attack planes during the Second World War to sink powerful US and British battleships. To battle these new threats, the Navy is employing modern long-range weapons, including universal ship installations, railguns, and lasers, which may change future warfare. Let's explore some of these technologies that would defend these expensive and important ships against aerial threats. Let's start with a special type of gun, the OTO Malera 76. This 76mm gun, also called the OTO 76/62 gun mount, is a naval autocannon made by the Italian company OTO Malera. This gun is small enough to fit on smaller warships. It has a fast firing rate and can use different types of ammunition, making it effective for close-range defense against missiles, aircraft, surface targets, and ground support. The ammo includes armor-piercing, incendiary, and guided rounds designed to target moving anti-ship missiles. It can also be hidden in a stealthy dome. One of the key features of the OTO Malera 76mm gun is its ability to perform multiple roles, including short-range anti-missile defense, anti-aircraft operations, and ground support. The gun's high rate of fire, combined with a diverse range of available ammunition, enhances its effectiveness in various combat situations. The cooling system of this gun utilizes seawater, while fresh water is used for flushing. For its electrical power supply, the gun operates on a main circuit of 4-voltage, 3-phase, and 60 Hz, along with a servo and synchro network operating at 115 voltage, 1-phase, and 400 Hz. This electrical configuration ensures that the gun operates efficiently under various conditions. The OTO Malera 76mm gun has several notable variants, each designed to meet specific operational requirements. The original compact variant features a circular dome and has a firing rate of 85 rounds per minute. In the early 1980s, the super rapid version was introduced, which includes a diagonal dome and a significantly faster firing rate of 120 rounds per minute, achieved through an advanced feed system. This enhanced rate of fire makes the super rapid variant particularly effective in high-pressure combat situations. The Strail system is another significant improvement to the OTO Melara 76mm gun. The Italian Navy favors this variant due to its enhanced capabilities in anti-missile defense, particularly when equipped with dart ammunition, which allows it to counter several subsonic missiles at ranges of up to 8,000 meters. This medium-caliber gun is also effective against surface targets, showcasing its versatility on the battlefield. Another innovative development is the 76/62 Sovraponte, a new compact and lightweight mount for the 76/62 gun. This system is approximately 30 to 40% lighter than the standard Super Rapid and can be installed without penetrating the deck below. It houses 76 ready-to-fire rounds and is available for sale with or without the Strail system. The Sovraponte mount was first installed on the Theon de Revel class patrol vessel of the Italian Navy, positioned above the helicopter hangar, emphasizing its compact design. To enhance the gun's versatility, OTO Melara provides a wide range of specialized ammunition suitable for various combat roles. The available types include high-explosive standard rounds, which weigh 6.296 kilograms and have a range of 16 kilometers. Other ammunition types include the multi-role OTO munition, anti-missile projectiles with proximity fuses and tungsten balls for fragmentation, and semi-armor-piercing SAPOM rounds, which have a range of 16 kilometers. The guided dart projectile is designed for engaging maneuvering aerial and missile targets, while the Volcano guided projectile, weighing 5 kilograms, can reach a range of approximately 40 kilometers. The fire control systems of the OTO Melara 76mm gun have also seen significant advancements over the years. Early versions, such as the compact model, utilized the RTN-10X Orion radar. Later, in the early 1980s, the more advanced RTN-30X radar was introduced. This new system is capable of managing various calibers, including 40mm, 76mm, and 127mm, as well as missiles like the Sea Sparrow and Aspide. The RTN-30X system first enters service with the Italian Navy on the Garibaldi cruiser and has since been equipped on numerous destroyers and frigates. The OTO Melara 76mm gun is a versatile and widely adopted naval autocannon that has undergone significant evolution since its inception, with its various models, including the Compact, Super Rapid, and Sovraponte, along with an extensive range of ammunition and advanced fire control systems. The gun remains a crucial asset for modern naval forces. Its ability to perform multiple roles, combined with innovative design features, ensures that it will continue to play a vital role in naval operations for years to come. Another weapon is the Phalanx CIWS. It is an automatic gun system used to protect military ships from threats like aircraft, missiles, and small boats. It was designed by General Dynamics, now part of Raytheon. The system features a radar-guided 20mm Vulcan cannon that can swivel to target incoming threats. The Phalanx is used by the U.S. Navy and 15 other countries, being deployed on almost all U.S. surface combat ships except the Zumwalt-class destroyer and San Antonio-class amphibious transport dock. Other users include the British Royal Navy, the Royal Australian Navy, the Royal New Zealand Navy, the Royal Canadian Navy, and the U.S. Coast Guard. A land version called the LPWS, or Land Phalanx Weapon System, was created as part of the counter-rocket, artillery, and mortar system. It was used to defend against rocket, artillery, and mortar attacks during the U.S. withdrawal from Afghanistan in 2021. The U.S. Navy also uses the CRAM system, which combines the RIM-116 rolling airframe missile with sensors similar to those in the Phalanx. It was developed as a last line of defense against incoming threats, including anti-ship missiles, aircraft, and small boats. The first prototype was tested by the U.S. Navy on the destroyer leader USS King in 1973. After improvements were made for better performance and reliability, the Phalanx operational suitability model passed its tests on the destroyer USS Bigelow in 1977. This model met all maintenance and reliability standards, leading to its production approval in 1978. The first orders included 23 for the U.S. Navy and 14 for foreign military systems. The first fully equipped ship was the aircraft carrier USS Coral Sea in 1980, and the Navy began installing CIWS systems on non-combatant vessels in 1984. The Phalanx system is built around the 20mm M61 Vulcan rotary cannon which the U.S. military has used on different aircraft since 1959. It uses a Ku-band fire control radar system to find and track targets. The system is mounted on a base that can quickly move up and down and side to side to follow incoming threats. This unit includes the gun, an automated fire control system, and other main parts, allowing it to automatically search for, detect, track, and engage targets using its computer-controlled radar. Its self-contained design makes it perfect for support ships, which usually don't have advanced targeting systems and have limited sensors. Failing CIW's units are sometimes nicknamed R2-D2 because of their round radar shape and automated function, resembling the droid from the Star Wars movies. In April 2017, Raytheon tested a new electric gun for the Phalanx, allowing it to fire at different rates to save ammunition. This new design replaces the pneumatic motor, compressor, and storage tanks, reducing the system's weight by 180 pounds while improving reliability and lowering operating costs. The United States has also invested in futuristic weapons to make these aircraft carriers more formidable. Some of these weapons include railguns and even laser weapons. A railgun, also known as a rail cannon, is a type of weapon that uses electromagnetic force to shoot projectiles at very high speeds. Unlike traditional weapons, the projectiles usually do not have explosives. Instead, they rely on their high kinetic energy to cause damage. A railgun has two parallel metal tracks and uses an electrical current to accelerate a sliding piece between them. This works similarly to how a homopolar motor operates. As of 2020, research has focused on using railguns as weapons because they can launch projectiles with much higher speeds compared to regular guns. Traditional guns can typically shoot projectiles at speeds up to about 2 kilometers per second, while railguns can easily reach speeds over 3 kilometers per second. This higher speed can give railgun projectiles a longer range and more destructive power, which depends on their kinetic energy when they hit a target. Since railguns do not need explosive propellants, the projectiles are also cheaper and safer to handle. However, railguns are still mostly in the research phase, despite many years of development. It is unclear if they will become practical military weapons soon. Any comparison between electromagnetic propulsion systems and traditional chemical propellants must consider factors like durability, availability, cost, and the complexity of the power supplies needed for electromagnetic launchers. How do these railguns work? A railgun has two parallel metal tracks, which is where it gets its name. One end of the rails connects to an electrical power supply, forming the back end of the gun. When a conductive projectile is placed between the rails, it completes the circuit. This allows electrons to flow from the power supply through one rail across the projectile and down the other rail back to the power supply. This flow of electricity makes the railgun act like an electromagnet, creating a magnetic field between the rails. According to the right-hand rule, the magnetic field moves around each rail. Since the electric current flows in opposite directions along the rails, the overall magnetic field between them pushes the projectile forward along the rails toward the front end of the gun. While there are forces trying to push the rails apart, they are held tightly in place so they do not move. If a current of 1 ampere flows through two long parallel wires 1 meter apart, the force on each wire will be 0.2 micronewtons. In general, the force increases with the square of the current and decreases with the distance between the wires. For railguns that shoot projectiles weighing a few kilograms and with a few meter-long barrel, very large currents are needed to reach speeds around 1,000 meters per second. A huge power supply capable of delivering around 1 million amperes of current can create a strong force that accelerates the projectile to speeds of several kilometers per second. However, these high speeds generate a lot of heat that can quickly wear out the rails. Railguns would need frequent rail replacements or the use of special heat-resistant materials. Experts agree that significant advances in material science are needed to create powerful railguns that can shoot more than a few times before needing new rails. The barrel must withstand this pressure for many rounds without breaking down. The power supply must provide large currents consistently and safely for a useful time. The most important measure of a power supply's effectiveness is how much energy it can deliver. As of December 2010, the highest energy used to fire a projectile from a railgun was 33 megajoules. Common power supplies for railguns include capacitors and compulsators, which charge slowly from other energy sources. The rails must handle strong forces during firing, which can push them apart from the projectile. If the gap between the rails and projectile increases, it can create arcs of electricity that damage the rail surfaces. This limited early railguns to only one shot at a time. The efficiency of a railgun is also limited by the inductance and resistance of the rails and power supply. Different rail shapes and designs are being tested, particularly by the US Navy and other research institutions. The rails and projectiles need to be made of strong conductive materials that can withstand the stress of firing. Some research incorrectly suggested that the recoil force in railguns could be redirected, but careful analysis shows that recoil acts on the breech closure just like in traditional guns. The rails also repel each other due to a sideways force from the magnetic field, just like the projectile. They need to be securely mounted to avoid bending. Major improvements in material science are needed before rails can be made that allow railguns to fire more than a few full-power shots before needing replacement. Railguns generate a lot of heat from the electricity flowing through the rails and the friction when the projectile exits. This creates three main problems: melting of parts, safety risks for personnel, and detection by enemy forces due to the increased heat signature. Firing such a device requires materials that can handle extreme heat. If not, the rails and other equipment could melt or be damaged. Most railgun designs experience erosion of the rails with each shot. Projectiles may also suffer some wear, which can limit the railgun's lifespan significantly. While the railgun technology is under the research phase, the United States has made a lot of progress with its research on laser systems. Let's check out the features and capabilities of one. The United States Navy's High-Energy Laser Counter Anti-Ship Cruise, or HELCAP missile project, is getting closer to transitioning its developed technology into an operational system. Currently, one San Antonio-class amphibious transport ship is equipped with a 150-kilowatt Mark II Mod 0 laser weapon system demonstrator. Additionally, 8 Arleigh Burke-class destroyers have the optical Dazzler interdictor Navy, and one destroyer has the 60-kilowatt high-energy laser with integrated optical Dazzler and surveillance or Helios system. HELCAP is different from these systems, which are designed for counterintelligence, surveillance, and reconnaissance by dazzling or destroying unmanned aerial systems. HELCAP specifically targets anti-ship cruise missiles in a crossing scenario, meaning it can defend against missiles aimed at nearby friendly ships. The US Navy started HELCAP in 2019 after the ruggedized high-energy laser Phase 1. HELCAP aims to address technical issues that laser weapons face, like advanced beam control, effects of atmospheric turbulence, precision tracking in cluttered environments, and automatic target identification and aiming. The results from HELCAP and years of technology development will come together to create the laser weapon testbed central to HELCAP. This testbed will use a 300-plus kilowatt laser developed under the High Energy Laser Scaling Initiative, which has funded teams to deliver these powerful lasers. The laser will be combined with a prototype beam control system created by the Navy and integrated with a power and cooling system. The LWT will be tested at the White Sands Missile Range this year, and the initial test will focus on the system's beam control, tracking, and optics performance. Afterward, it will be tested against increasingly complex targets, starting with stationary ground targets, then moving targets, and eventually low-cost unmanned aerial targets in cruise missile surrogates. Once completed, this program will help improve future systems based on the Surface Navy Laser Weapon System Increment 1. Currently, there are no plans for the program to leave behind any assets or prototypes for ship integration. Elon Musk just made a jaw-dropping announcement. A game-changing aircraft with groundbreaking abilities is ready to take flight, and the world is watching. Recently, countries like Israel and Iran introduced their hypersonic aircraft. However, this aircraft, known as the SR-72 Darkstar, is set to break every record and completely reshape the future of modern warfare with its mind-blowing speeds and unmatched stealth. What are the specific features of this aircraft? What does this mean for the global balance of power? Join us as we explore what Elon Musk revealed about the SR-72 Darkstar that is finally ready to fly over the skies. The skies have always been dominated by aircraft like the SR-71, which fly faster and higher than any plane ever imagined. The SR-71, also known as the Blackbird, an incredible example of aircraft engineering, was once the most powerful aircraft, soaring at speeds and altitudes that seemed impossible. Yet when it retired, the world wasn't prepared for what was coming next, and that was the SR-72. The SR-72 Darkstar, a hypersonic drone developed by Lockheed Martin's Skunk Works, is taking over with speeds and capabilities that are beyond belief. The origin of the SR-71 begins with an unfortunate event during the Cold War. In 1960, U.S. pilot Gary Powers was shot down while flying a U-2C Dragon Lady over Soviet territory. This event highlighted the vulnerability of high-altitude reconnaissance aircraft, and it forced the United States to rethink its approach. Radar and missile technology were advancing rapidly, making the U-2 increasingly easy to detect. The need for a faster, stealthier plane was clear. The CIA tasked Lockheed's secret Skunk Works division with developing a new spy plane. It was led by Kelly Johnson, and the team created the A-12, a prototype that eventually gave birth to the SR-71 Blackbird. The goal was to design an aircraft that could fly higher and faster than anything before it, while being nearly invisible to radar. It had to outpace any missile that could be fired at it and capture intelligence in hostile territories without ever being touched. The A-12 flew missions over North Korea and North Vietnam during the 1960s, reaching speeds of Mach 3.1 at altitudes as high as 88,000 feet. It was the fastest plane in the world at the time, and its impressive speed made it nearly impossible for enemy defenses to shoot it down. But even as the A-12 was proving its worth, it was already being overshadowed by the SR-71. The SR-71 became public in July 1964 and officially began serving the U.S. Air Force in January 1966. In 1989, the Air Force decided to retire the SR-71, mainly for political reasons. A few of the jets were brought back into service temporarily before they were fully retired in 1998. NASA used the Blackbird as a flying laboratory for research purposes before retiring it as well. In 1999, the SR-71 had a secret start, as it served the Air Force for a while, had a brief return, and then worked for NASA before its final retirement. The SR-71 had special equipment for its spy missions, such as sensors to intercept signals, radar for ground observation, and a camera. When it went on missions, it flew fast and high, reaching speeds of Mach 3.2 and altitudes of 85,000 feet, making it extremely difficult for enemies to catch or attack. If it detected a missile coming, the SR-71's trick was to speed up quickly and leave the missile behind. After each mission, the SR-71 required extensive checks and maintenance before it could fly again, which limited it to about one flight per week on average. A total of 30 SR-71 planes were made, but unfortunately 12 were lost in accidents, though none were lost in combat. After its retirement, other technologies like spy satellites and pilotless drone took over the roles the SR-71 once filled. The SR-71 was more than just a faster version of the A-12. It was a complete reimagining of what an advanced aircraft could be. While the A-12 was a single-seat aircraft designed for specialized missions, the SR-71 had a two-seat cockpit, more fuel capacity, and enhanced capabilities. It was equipped with advanced cameras and sensors that could collect data in greater detail and from a wider field of view than its predecessor. The Blackbird quickly began setting records that still stand today, making it the fastest jet aircraft ever built. In 1974, it set a record for the fastest flight between London and New York, completing the trip in just under 2 hours. No other aircraft has matched its sustained speed or altitude, even decades after its retirement. And during the Vietnam War, the SR-71's evasiveness became legendary. North Vietnamese forces fired more than 800 surface-to-air missiles at it, but none ever hit their target. The plane was simply too fast. Despite its incredible performance, the SR-71 was expensive to maintain. By the late 1980s, the U.S. Air Force decided to retire the fleet, citing the high costs of keeping the aircraft operational. Critics argue that this decision was influenced more by politics, but by the early 1990s, only NASA continued to fly a few Blackbirds for research purposes. The remaining planes were placed in museums, where they became icons of aviation history. For years, there was no clear successor to the SR-71. The F-22 Raptor and F-35 Lightning II emerged as advanced fighters, but they weren't designed to survey. The United States seemed to have no immediate replacement for the Blackbird. That changed in 2013 when Lockheed Martin announced the development of the SR-72, a hypersonic drone that would surpass the SR-71 in almost every way. The SR-72's development comes at a time when other nations, like Russia and China, are also racing to develop hypersonic technology. In 2018, Russian President Vladimir Putin unveiled the Ko-47M2 Kinzhal, a hypersonic missile capable of reaching Mach 10. This announcement marked the beginning of a new weapon race, with the United States, Russia, and China all fighting for power in the hypersonic world. The SR-72 Darkstar is referred to as the son of Blackbird, a name that acknowledges its predecessor's legacy. Even though the SR-71 broke every record for speed and altitude, flying at Mach 3.3 and above 85,000 feet, the SR-72 is set to double those limits, pushing the boundaries of technology to Mach 6, which is twice the speed of sound at those altitudes. Such speeds make the Darkstar nearly impossible to detect or intercept, rendering it a true nightmare for any enemy defense systems. One of the key aspects that makes the SR-72 so special is its dual-mode engine system. Traditional jets rely on one engine type, but the SR-72 has both a turbine engine for slower speeds and a scramjet engine for hypersonic flight. At lower speeds, the turbine engine provides the thrust, much like the engines found in commercial and military jets today. But as it climbs higher and faster, reaching supersonic speeds, the scramjet kicks in. This engine is unlike anything used in regular aircraft. It relies on the plane's own speed to compress the incoming air, which then mixes with fuel and ignites, creating an explosion of power that propels the aircraft even faster. Flying at these hypersonic speeds generates incredible heat. At Mach 6, the air friction alone can raise the temperature on the surface of the aircraft to over 3,500 degrees. This would melt most materials, but Lockheed Martin has developed new heat-resistant composites specifically for the SR-72. These materials, including advanced ceramics and carbon compounds, are designed to maintain their structures even under extreme temperatures. This development makes sure that the SR-72 can operate at such speeds without breaking apart, a problem that would have been impossible to solve even just a few years ago. The role of the SR-72 goes beyond simple observation. Its speed and altitude make it the perfect spy drone, as it is able to gather intelligence from virtually anywhere on Earth. The SR-72 can be armed with hypersonic weapons, allowing it to strike targets at incredible distances with incredible accuracy. This makes it not only a surveillance tool, but also a powerful attacking weapon, capable of delivering damaging attacks with little to no warning. The concept of hypersonic flight has been a topic of research and development for decades. But recent developments in materials science and propulsion technology have finally made it a reality. The SR-72's predecessor, the SR-71, was already a game-changer, but it relied on older technologies that limited its capabilities. The SR-72 represents the next step in this evolution, using state-of-the-art technology to achieve speeds and capabilities that were once thought impossible. Lockheed Martin's Skunk Works division, known for its secrecy and cutting-edge projects, has been working on the SR-72 for many years. The project was made public years ago, but development had been underway long before that. The goal was always to create a plane that could not only fly faster than the SR-71, but also operate autonomously. One significant development in aircraft is the shift to automated flight. The SR-72 is now able to conduct high-risk missions without risking the lives of its pilots. Like any new technology, there have been issues with the SR-72. Developing a plane that can fly at Mach 6 is not an easy task, and Lockheed Martin has overcome many technical challenges. A few years ago, the propulsion system needed to achieve such speeds was still in the early stages of development, and the materials needed to withstand the heat of hypersonic flight were scarce. But thanks to advancements in computer modeling and technology, the engineers were able to bring the SR-72 to life. These technologies allowed them to design and create components that would have been impossible to build using traditional methods. One of the most impressive aspects of the SR-72 is its stealth capabilities. At such high speeds, the heat generated by the plane would typically make it easy to detect using infrared sensors. However, the engineers incorporated advanced cooling systems and radar-absorbing materials into the design of the Dark Star, making it nearly invisible to both radar and infrared detection. This stealth, combined with its speed, makes the SR-72 one of the most difficult aircraft ever created. With its ability to travel faster than any current missile defense system can react, the SR-72 can perform missions that were previously thought to be impossible. With its ability to deliver accurate strikes and gather intelligence, the Dark Star has the potential to completely change the way war is fought and won in the 21st century. For years, the idea of a hypersonic aircraft has been more fantasy than reality. The SR-72 is finally ready to take flight, bringing with it capabilities that are set to be more advanced than other aircraft. Flying at extreme speeds doesn't just make the SR-72 fast, but it also makes it almost untouchable. The fastest missiles and interceptors that enemy forces might deploy simply won't be able to keep up with the Dark Star. This kind of speed changes the rules of warfare. In a world where hypersonic aircraft dominate, speed itself becomes the greatest defense. But speed alone isn't what makes the SR-72 such a formidable force. The aircraft's design has been fine-tuned to enhance both its stealth and survivability. Stealth has long been a key factor in military aviation, and the SR-72 takes this to the next level. Not only is the aircraft invisible to most radar systems, thanks to its radar-absorbing materials, but it is also difficult to track. This combination of speed and stealth makes the Dark Star an incredibly effective tool for both reconnaissance and combat missions. It can enter hostile territory undetected, gather crucial intelligence, and leave before enemy forces even realize it's there. The development of the Dark Star involved overcoming challenges that seemed impossible just a decade ago. The extreme temperatures generated by hypersonic flight required a new approach to aircraft materials. Traditional metals would simply melt at the temperatures the SR-72 would experience. The engineers turned to composites that could withstand heat up to over 3,000 degrees. These materials, including carbon fiber and ceramic compounds, are not only heat-resistant, but also lightweight, making the aircraft both fast and efficient. The propulsion system was another major issue. Developing a scramjet engine that could operate at such high speeds required years of research and experimentation. A scramjet doesn't use traditional rotating parts like a turbine engine. Instead, it uses the force of the air rushing into the engine to compress and ignite fuel. This is why the SR-72 must first accelerate to supersonic speeds before the scramjet can engage. Once it does, the plane can achieve speeds that no other aircraft can match. The development of this powerful aircraft has always struggled with funds because the U.S. Air Force initially focused on other projects. However, interest in the Dark Star increased as the need for hypersonic abilities became visible. The engineers have been working closely with both NASA and the U.S. military to develop the technologies necessary to make the SR-72 a reality. With successful tests of the engine system and materials already completed, the Dark Star is said to launch and become the most advanced aircraft in the world. The arrival of the SR-72 Dark Star marks an important moment in aircraft, an achievement that challenges the boundaries of what we believed was possible in the skies. For years, the thought of an aircraft flying at hypersonic speeds seemed impossible, but now the SR-72 stands on the verge of becoming a reality. The Dark Star is designed to change both surveillance and combat, giving the U.S. military a significant advantage over other countries. While its predecessor, the SR-71 Blackbird, was unique for its time, the SR-72 takes everything to the next level. The SR-71 broke records with its Mach 3 speed, but the SR-72 is capable of flying at Mach 6. This dramatic increase in speed makes the Dark Star nearly impossible to catch or track, but it also presents a host of engineering challenges that the engineers had to solve. The aircraft's ability to withstand the extreme conditions of hypersonic flight serves as proof of the advancements made in aerospace technology over the past few decades. The journey to bring the SR-72 to life has been a long and difficult one. However, Lockheed Martin and his engineers have a long history of overcoming obstacles and pushing the boundaries of aircraft technology. The SR-72 is the result of decades of research and development, and its successful debut will mark the beginning of a new era in aerial warfare. The most exciting thing about the SR-72 is the potential it holds for future advancements. The Dark Star is not just a one-off project, but it's a platform that could lead to even more advanced technologies in the years to come. As materials and propulsion systems continue to evolve, it's possible that the next generation of hypersonic aircraft will be even faster, stealthier, and more capable than the SR-72. This aircraft represents the cutting edge of what's possible today, but it also serves as a stepping stone for the aerial technologies of tomorrow. Looking forward, the Dark Star is just the beginning. The technologies developed for the SR-72 will pave the way for even more advanced hypersonic aircraft in the future. As materials science and propulsion systems continue to improve, it's possible that future generations of aircraft will surpass even the capabilities of the Dark Star. The SR-72 serves as a blueprint for what is possible, pushing the boundaries of flight and setting new standards for speed, stealth, and operational flexibility. In 2021, a glimpse of the SR-72's potential emerged when the Air Force released a video of a single-engine flight research aircraft that bore a striking resemblance to the SR-72. While details about the drone's capabilities remain scarce, this video revived interest in the project. Aviation fans believe that Lockheed was getting closer to a working prototype. The SR-72 isn't just a spy drone. It's a platform for launching hypersonic missiles. Releasing missiles at such high speeds presents its own set of challenges. But Lockheed Martin has already proven that it's possible to launch air-to-air missiles at speeds greater than Mach 3 using the YF-23, an interceptor based on the Blackbird. The SR-72 will take this capability to the next level, making it a formidable asset in the U.S. military's arsenal. As of now, the SR-72 first flight is scheduled for 2025, with full operational deployment expected by 2030. If successful, it will mark a new era of aerial power. The SR-72 will not only surpass the SR-71's speed and altitude records, but also introduce new possibilities for survey and strike capabilities. However, there are still many questions about whether the United States can maintain the budget to support such a program alongside other advanced projects like the 6th-generation NGAD fighter and the B-21 Raider bomber. The SR-71 Blackbird was a legend in its time, and its legacy endures. But as we look to the future, the SR-72 represents the next step in aviation evolution. Its hypersonic speed, advanced materials, and cutting-edge propulsion technology will allow it to perform missions that were once impossible. Whether it will fully live up to its promise remains to be seen. As Elon Musk has boldly declared, the SR-72 is ready to fly, and with it comes the dawn of a new era in aviation. This aircraft is not just a tool of war, but it is a symbol of human creativity and the relentless search for progress. The skies will never be the same, and the world will watch in awe as the Dark Star takes to the air, blazing a trail for the future of flight. As geopolitical tensions continue to rise, the U.S. is gathering all its war assets, preparing for the worst. This country is upgrading its legendary aircraft that's been flying for nearly 100 years. While the rest of the world is in shock at the newest and most advanced version of this aircraft, the famous B-52 bomber is gearing up to dominate the skies. What's so unique about these new B-52, and how are they going to affect the power changes? Join us as we explore the upgraded features of the brand B-52s to fly for a full century that is ready to take over the world. In a world where technology is developing at a fast rate, where invisible drones and fast bombers rule the news, one aircraft stands surviving against the passing of time. The B-52 Stratofortress is a powerful aircraft that defies gravity and was originally launched more than 70 years ago. As the United States tests its latest B-52 models, plans are in motion to keep these incredible bombers flying for a full century. Can you imagine an aircraft flying for that long, witnessing the evolution of warfare and adapting to changing combat needs? It sounds almost unbelievable, yet here we are, on the brink of history. The B-52 is an example of American military power and dedication, not merely a fighter aircraft. This aircraft was first developed in the years following World War II with the purpose of carrying nuclear missiles deep into enemy territory. Its basic design hasn't changed over the years, despite several upgrades and modifications. Early in 1946, Boeing began working on the B-52 project. The task was clear: create a bomber capable of covering great distances up to 5,000 miles at a minimum speed of 450 miles per hour. After a year of serious work, an incredible aircraft with engines placed on its wings was designed. The project, which was once known as Model 4229, was nearly satisfied with all of the U.S. government's standards. But after the first two models were turned down, problems surfaced. Boeing's engineers kept on working and never gave up. And then they went forward and quickly developed a new model. One of the main designs developed was the two-level cockpit, which was created to increase crew performance. For more than 60 years, the model served as the basis of American military aircraft. The main aim was launching powerful thermonuclear bombs far inside Soviet territory. Even though the aim was achieved because of the Soviet Union's collapse, which brought about a major global crisis, the B-52 continued to be an important part of American military plans. The B-52 has been involved in almost every combat mission the United States has carried out since the aircraft's launch. Its excellent flight range and several upgrades have led to a wide range of changes. For example, the B-52A was supplied with improved radar technology, enabling it to function as a spy aircraft. One of the characteristics that set the aircraft apart and made it a true game-changer in the sky was its ability to adapt. The B-52H, the newest and most powerful version, has upgraded weapons that allow it to successfully complete any mission. In order to test new weapons and technologies, test aircraft have also been built, showing the B-52's ability to adjust to changing times. This aircraft has repeatedly shown its worth by successfully accomplishing important missions that have influenced modern warfare. After World War II, atomic weapons had been developed, completely shifting the balance of power in the world. The B-52 was perfectly placed to drop these powerful weapons. Due to its amazing height of up to 55,000 feet, it remains outside the detection range of a lot of radar systems. When combined with its top speed of around 620 miles per hour, the B-52 is able to hit targets with speed and accuracy. It can go extremely far without fuel thanks to its uncommon 10,000-mile flying range. Though its primary purpose was to carry nuclear weapons, the B-52 abilities have grown. Up to 70,000 pounds of free-falling explosives were fitted to the early versions. The bomber was a powerful machine due to its large load capacity, but Soviet anti-aircraft missiles posed a serious threat. As a result of these missiles' ability to engage targets at 80,000 feet, methods changed by the middle of the 1950s. In order to adjust, the B-52 began to use new weapons, such as advanced precision-guided bombs and air-launched cruise missiles. With these changes, the aircraft was able to escape the center of the enemy's air defense systems and hit targets at a safer distance. After improvements in the middle of the 1980s, the B-52 was armed with non-nuclear weapons such as the deadly AGM-100 and 42 Raptor missiles produced in Israel and the powerful Harpoon anti-ship missiles. With these weapons, the B-52 could engage a variety of threats, including enemy ships and land targets, improving its popularity as a flexible weapon system. However, the B-52 uses more than simply force. It has an amazing range and power, using gasoline from 12 tanks to power 8 different engines. Another amazing thing is to refuel while in the air, which would allow the B-52 to remain in the air for a longer period of time. The aircraft's advanced bombing and navigation systems enable accurate targeting in a variety of situations. Technology also played an important part in the aircraft revolution. YF-23 radars, which were among the best on the market at the time, were first installed on B-52s. The AQ-151 optoelectronic vision system is now used in later versions, due to improvements in technology over time. The B-52 can now fly past obstacles at low speeds thanks to this technology, which is important for a big bomber that often needs to fly in crowded areas. The B-52's night vision and infrared capabilities enable it to detect enemy positions that are hidden. Its electronic warfare system is one of its most important weapons. This advanced technology may give incorrect information and fool opposing radar, making it very difficult to shoot down. According to Pentagon current plans, the B-52 will continue to be an important component of U.S. military aircraft through at least 2030. The U.S. government is making major investments in upgrades, guaranteeing that the Stratofortress would be loaded with upgraded weapons, engines, communication systems, and sensor systems. Its lifespan will be increased by several years with these modifications, improving its ability to operate. The upcoming upgrades of B-52 will require less aerial refueling, which will result in a 30% decrease in fuel expenses and less maintenance time. Crews will be able to get intelligence in real time and change their operations in response to updated data thanks to new radar and surveillance devices. This ability to adapt is necessary in today's battle, as success depends heavily on intelligence. Additionally, the B-52 will be modified with a state-of-the-art internal weapons room that can hold the newest bombs from the JS series. The B-52's load was formerly limited since it could only carry joint direct attack munition on external hardpoints. Now that internal precision-guided bombs have been formed, their firepower will significantly rise. The addition of the MJ decoy missile will further improve the B-52's undercover qualities, increasing its combat strength. However, all these upgrades come at a hefty price, with estimates around $12 billion. Opinions vary on whether this investment is necessary. Some experts argue that, despite the upgrades, the B-52 is outdated and that funds should go toward newer aircraft. Others argue that military operations may be handled more effectively and economically by updating old and reliable ones. As the B-52 prepares for its future, it stands as an example of American power and military strength. An aircraft that has withstood the test of time is set to continue flying for decades to come. This legendary bomber is not merely a relic of the past. It's a vital part of the future of U.S. military aviation. At the core of the bomber's operational strategy is its ability to adapt. The aircraft may be set up for a number of tasks, including carrying out operations to gather intelligence and delivering targeted attacks. Because of its ability to adapt, the B-52 can successfully respond to developing threats and change course in response to changing combat conditions. The B-52 has gone through several upgrades since its introduction. However, one of the things that has remained largely the same is the plane's engines. It features 4 dual-engine pods consisting of 8 Pratt and Whitney TF and 103 turbofan engines. Each of these can produce around 17,000 pounds of thrust. This is necessary, as a fully loaded B-52 can weigh as much as 488,000 pounds. Due to their age, the TF-33 have earned a reputation for requiring a lot of care. And sometimes they can also take a long time to warm up to an hour. Of course, in the event of an emergency, the Stratofortress crew needs to be able to get up and go into the air as soon as possible. This has given rise to clever solutions like Card Start. In this case, the turbofans are provided with tiny devices that resemble shotgun shells. They provide quite a lot of compressed gas when they explode, which turns the compressor and gets the jet airborne in a matter of minutes. In early 2023, the United States military announced it was working on upgrades that would eventually allow the B-52 to serve for more than 100 years. The most notable of these improvements would replace the TF-33 engines with new Rolls-Royce F-130. These new engines produce the same amount of thrust, but they are far more energy-saving. Moreover, they will turn out to require a lot less maintenance than the engines that the B-52 already runs, which might save the country billions of dollars in the next several years. The search for these brand new F-130 dual-engine pods began in February and is anticipated to last the entire year. Although 13 different B-52 versions have been built throughout the years, the U.S. military still invests a large amount of time, resources, and money into improving and upgrading the fleet's current aircraft. One of the upgrades was the Connect system, which stands for Combat Network Communications Technology. The specific goal of Connect was to improve the B-52's performance in modern combat situations. It does this through increased battle unity, improved communication, and improved awareness of situations. The bomber may easily and securely share data with allied aircraft, ground stations, and command centers, thanks to the Connect technology. It allows better communication and information exchange by supporting both classified and unclassified networks. Additionally, the system has advanced sensors, a display, and data fusion abilities to help the crew be more ready for any situation that may arise during a flight. The original B-52 was designed to carry traditional weighted bombs, which had to be dropped from its 2 bomb bays onto various targets. But this design does not have the ability to adapt. This is the reason why the Common Strategic Rotary Launcher has been installed on a large number of B-52s. This rotating weapon system can fire a variety of bombs, missiles, and smart weapons. With a simple flip of a switch, the crew may rapidly change the sort of weapon it uses depending on the situation at hand. This not only provides an important edge in firepower, but it also significantly improves mission flexibility. Because of its long range, the B-52 is a perfect platform for dropping bombs well into enemy territory. Apart from its usual function as a major bomber, the B-52 has been used for close air support in diplomatic missions as well. It is a useful tool in joint operations because of its capacity to carry a variety of weapons, which enable it to help ground forces. This flexibility is an important aspect of the B-52's history and demonstrates its continuing significance in modern military planning. The evolution of warfare has also prompted the B-52 to adapt to advanced technologies. One of the most significant changes is the addition of data link systems that allow the bomber to share information in real time with other aircraft and ground forces. This communication approach improves awareness of the situation and enables targeted strikes, maximizing the usefulness of the B-52 in challenging combat conditions. Moreover, the B-52 is capable of sending power anywhere in the world due to its ability for long-range operations. This worldwide reach is important for prevention because it enables the United States to act quickly in the event of a danger. The B-52 may be sent to faraway places, proving the military strength and power of the United States without requiring large-scale ground operations. As we look at the B-52's improving efforts, this requires us to take into account the larger picture of U.S. military rules. The Pentagon understands that a force that is both different and flexible is necessary to meet the needs of an international situation that is changing quickly. The B-52 must adapt as enemies make developments in fresh tools and technology in order to stay competitive. The U.S. military's wider method for upgrading older systems to match more recent platforms includes the B-52. With this strategy, the military can include the latest technologies while making the most of its current capabilities. The B-52 is an important part of this plan due to its wealth of experience and history of success. We may anticipate seeing many more improvements to the B-52 in the upcoming years. The aircraft will become an even more powerful weapon in the sky as it continues to get changes. The addition of powerful weapons, upgraded aircraft, and better communication systems will guarantee the B-52's durability and usefulness within a difficult operating environment. The B-52 has a bright future, even if its history has endured deeply in the past. A commitment to updating and spending on modern technology guarantees that the B-52 will be an important part of American military operations for many years to come. Nonetheless, the U.S. military has experimented recently with dropping weapons like the B-61 nuclear weapon from fighter planes. One successful attack would be all it would take to change the course of a conflict, since nuclear weapons are so much more destructive than traditional weapons. A fighter such as the F-15 Eagle could leave the enemy's airspace at over twice the speed of sound, but an ultrasonic aircraft would need hours to do it. The first F-15 entered the arsenal of the United States in the middle of the 1970s, but the Air Force quickly understood that in order to be competitive in the global market, a new kind of aircraft was required due to changes in the nature of combat. As a result, the F-15E Strike Eagle was created. The Strike Eagle is designed for air-to-air and air-to-ground combat situations. It also has upgraded mission systems, radar capacity, aircraft, and an advanced electronic warfare system. Additionally, the two-seater EX has updated engines with better performance and fuel efficiency. Finally, a wider variety of weapons such as missiles, rockets, explosives, and more may be carried by the upgraded version. The same company that performed the B-52 upgrade also handled the Eagle II upgrade. The company's engineers made the decision to fit the EX with two F-100 PW200 and 29 Pratt & Whitney engines. Even though they are a little heavier than the original engines, they can push up to 29,000 pounds when using afterburners and 17,800 pounds when operating normally. This amounts to a 3,000 and 5,000 pound gain, respectively. The Ego Passive Active Warning and Survivability System, which improves awareness of situations, danger feeling, and electronic warfare abilities, is a feature of the upgraded sensor systems and aircraft of the EX. Another effective but outdated multi-role fighter aircraft is the F-16 Fighting Falcon. One of the most versatile aircraft in American military history, the F-16 was first introduced in 1979 and was specifically designed to be a low-cost, lightweight aircraft that could perform a wide range of missions without requiring a new setup for air-to-air combat, air-to-ground strikes, reduction of enemy air defenses, close air support, and surveillance. Even though the Fighting Falcon is still in use today, it has had to undergo a number of electronics and weapon system improvements in order to compete with modern fighters and ground-to-air defenses. In 2012, manufacturer Lockheed Martin began working on a newer F-16 variant known as the F-16V or Block 70 variant. This highly advanced model would use various modern technologies to improve the plane's combat capabilities, awareness of situations, and capacity to withstand new threats. The powerful AESA radar system on Block 70, which offers better target identification, tracking, and electronic warfare capabilities, is one of the most significant improvements. Every update on an aircraft is completed in the factory. The Legion Pod was a new external sensor pack that Lockheed Martin released for the F-15 and F-16 at the beginning of the 2000s. As the study of the B-52 comes to an end, the B-52 Stratofortress is more than simply a piece of equipment. From its conception to its predicted future, it is a living legacy that is still influencing military aircraft today. The B-52 is prepared to take on any challenge that comes in a world of uncertainty. Its legacy is one of strength, flexibility, and determination, a real testimony to the power of the American military. We can be sure that the B-52 Stratofortress will keep rising in the future, surpassing expectations and creating new standards for future generations. In the world of military aviation, the B-52 Stratofortress is a unique masterpiece. As we watch it evolve, we witness not just the technology improving, but also the commitment of a nation to maintain its military readiness. The future may be unpredictable, but one thing is certain. The B-52 will continue to play an important role in the defense of freedom, security, and peace. The U.S. aircraft carriers are finally becoming the most powerful vessels in the world. This country recently unveiled a game-changing weapon, an incredibly powerful laser carrier that is designed to take on the growing hypersonic missile threats with their unprecedented firepower and advanced technology. How is this new laser carrier better than the regular missile defense system? How effective are they against China's hypersonic missiles? Join us as we unveil the capabilities of the new powerful laser system that the United States recently unveiled. Aircraft carriers first proved their importance during the Second World War. When Japan attacked Pearl Harbor using planes launched from carriers on December 7, 1941, it showed how powerful these ships could be. After that, aircraft carriers became the most important warships. They were key in major sea battles in the Pacific, like the battles at Midway, the Coral Sea, and Leyte Gulf. These floating air bases have been the core of the U.S. Navy's offensive power for years. Today they're bigger and more advanced than ever, but also more vulnerable to the growing number of America's enemies, especially China's Navy, the People's Liberation Army Navy. As a result, many are questioning whether the massive cost of building and maintaining them is still justified. This situation gets even worse. The Chinese military has created targets shaped like an American aircraft carrier and other U.S. warships in the Taklamakan Desert based on satellite photos shared by Maxar with USNI News. The targets include a full-sized outline of a U.S. carrier and two Arleigh Burke-class destroyers built in central China's Ruqiang region. This area is near a place China used in 2013 to test its YF-23 anti-ship missiles, known as carrier killers. The new range suggests that China is still focused on developing weapons to target U.S. Navy ships, with this site being more advanced than Iran's similar target in the Persian Gulf. The carrier target appears to be a flat surface without key features like the island, aircraft lifts, or weapons. according to Maxar images. On radar, the carrier's outline is clearly visible, standing out from the desert like a target, as shown in images from Capella Space. There are two more carrier-shaped targets without metal, but their outlines still show they represent carriers. Other warship targets are more detailed, with many upright poles that could be used for instruments or radar reflectors to imitate the ship's structure. The facility also has a large rail system, and an image from October 9 showed a 75-meter-long target with advanced equipment on a 6-meter-wide rail. The area has been mainly used for ballistic missile testing, according to a review of Maxar images by All Source Analysis, a geospatial intelligence company that identified the site with satellite imagery. The mock-ups of likely U.S. warships, some on rails and movable, might be used to test target detection and tracking, though no signs of weapon impacts were seen nearby. The detailed setup, including sensors around the targets, suggests the area could be used for different purposes over time. Satellite images show the carrier target was first built between March and April 2019, rebuilt a few times, and mostly taken apart by December 2019. The site became active again in late September this year, with the structure nearly finished by early October. China has several anti-ship ballistic missile programs managed by the People's Liberation Army Rocket Force. The land-based YF-23 missile can hit targets over 800 nautical miles away and has a maneuverable warhead to strike ships. The larger YF-26 has a range of about 2,000 nautical miles. According to a Pentagon report, the Chinese military fired 6 YF-23 missiles into the South China Sea, north of the Spratly Islands, on July 2019. China is believed to be developing a longer-range anti-ship missile that appeared in 2016. The YF-26 can quickly switch between conventional and nuclear warheads and can carry out precise strikes on land or at sea in areas like the Western Pacific, Indian Ocean, and South China Sea. In 2020, China tested these missiles against a moving target in the South China Sea, but has not officially confirmed it. China is also developing a program to equip its Navy's H-6 bombers with a large anti-ship missile that was revealed in 2018. This missile, called the CHS-X-13, could be the largest air-launched missile and might carry a hypersonic warhead. Another platform for launching anti-ship missiles could be China's new Type 55 Renhai-class large destroyer, which the Pentagon report says will be able to carry such missiles. This isn't the first time China has built a carrier target in the desert. Since 2003, a large concrete pad the size of a carrier has been used as a target at the Shuangchengzi missile test range, regularly hit and repaired. The newer site in the Taklamakan Desert, 600 miles away, is more advanced, with ship targets that better resemble real vessels. There are still questions about which weapons will be tested at the new facility, but the advanced setup shows that the Chinese military is continuing to develop ways to reduce the effectiveness of U.S. naval forces near China, especially focusing on U.S. aircraft carriers. The Pentagon report from last week states that one of the main goals of China's rocket force is to keep U.S. carriers under threat from anti-ship ballistic missiles across the Western Pacific. To safeguard its extremely important warship, the USS Gerald R. Ford, the U.S. Navy is pulling out all the stops, arming it with the most powerful laser weapon ever developed. The USS Gerald R. Ford isn't just any ship. It is a nuclear-powered vessel that boasts of 2 nuclear reactors, each weighing over 1,000 tons. These reactors endow the ship with exceptional longevity, giving it the potential to power an entire city without interruption. Placed within its core are its 2 Bechtel A-1B nuclear reactors, which generates about 700 megawatts of power, equivalent to an astounding 952,000 horsepower, or nearly 2 million horsepower through its pair of colossal electric motors. Each motor is equivalent in size to 4 pickup trucks stacked together, generating power equivalent to 1.5 million horsepower. This floating vessel carries over 60 fighter jets, support, and tactical aircraft, with room for up to 90. Towering 25 stories above the water and weighing 97,000 tons, which is 32,000 tons heavier than the biggest battleships of World War II, it's a true behemoth. Amongst all the aircraft carriers in the world, the USS Gerald R. Ford claims the title of the largest aircraft carrier, enabling it to support various aircraft, helicopters, and UAVs, including the most sophisticated and advanced fifth-generation fighter jets. Mounted on this aircraft carrier is a Mark 15 Phalanx close-in weapon system, an unmistakable symbol of excellence within anti-aircraft artillery systems. Its illustrious reputation is well-earned, as it proudly boasts a remarkable rate of fire, capable of discharging an astounding 4,500 rounds per minute, and an initial projectile velocity reaching an impressive 3,600 feet per second. In inoffensive engagements, the Phalanx orchestrates a relentless ballet of projectiles, evoking the precision and swiftness of a laser-like performance. Notably, the USS Gerald R. Ford has a forward-looking weapon system, Lockheed Martin's Laws shipboard laser system. This state-of-the-art system draws formidable power from the aircraft carrier's nuclear reactor, enabling a sustained offensive against hostile aircraft and missiles at a substantial distance of 3 miles. The laser's devastating potency is sufficient to hinder aircraft electronics or obliterate projectiles approaching the USS Gerald R. Ford. Its massive 5-acre flight deck and cutting-edge technology are designed to keep it dominating the seas well into the 2050s and beyond. However, due to its immense size, the carrier is incapable of nimbly skimming across the water like a race car. The ship has almost 3 times more power than America's current supercarriers, producing about 300 megawatts of electricity, according to the Navy. Seeing it on the water is like watching a block of New York City moving at 34 miles per hour. However, new missiles from China, some of which can travel faster than 5 times the speed of sound, might make the USS Ford and the Navy's Pacific Fleet outdated. A serious report from Congress, which was updated in August 2022, has raised concerns about whether Navy ships can survive in combat against opponents like China, who have many drones and advanced missiles. Even though Russia also has hypersonic weapons, the Navy is more concerned about China. In the last decade, China has quickly grown its Navy and developed many anti-ship weapons, including missiles that can move faster than 10 times the speed of sound. China openly states these weapons are meant to stop American ships, and one of their test sites even has life-size models of U.S. aircraft carriers for practice. The USS Ford and similar ships have defenses against missiles, but these said defenses are not strong enough to fully protect them in a long fight against China's newest and quite advanced weapons. To stay in control of the Pacific and keep its ships safe, the Navy is investing heavily in a technology that has been hard to develop: lasers. Lasers have exciting benefits. Not only are they powered by large energy sources like the Ford's nuclear reactors, they can also fire at the speed of light, which makes them a good match for hypersonic weapons. They can also be reloaded quickly to fight off large numbers of drones, and since they don't need ammo, ships would have almost endless firepower. In 2021, the Biden administration created a Pentagon task force to assess the threat from China's fast-growing Navy. A year later, based on what the task force found, the Defense Department identified China as America's main strategic rival. China now has over 770 military vessels, more than double the U.S. fleet, and most of them are focused in the Pacific, while the United States splits its fleet between the Atlantic and Pacific. China's hypersonic weapons aren't the only danger. Carrier commanders have long known that large numbers of anti-ship cruise missiles are also a big threat. These missiles can overwhelm a ship's defenses, and swarms of cheap, long-range suicide drones could just as easily damage a carrier group. The Navy's problem is clear. Its largest carriers and most heavily armed destroyers aren't prepared to handle large numbers of airborne attackers. Right now, the USS Gerald R. Ford sails with a carrier strike group, a fleet of 10 or more cruisers, destroyers, and frigates, sometimes joined by a submarine or 2. At least 2 of these ships, usually Arleigh Burke-class guided missile destroyers, focus on air defense. They use powerful radars to detect threats more than 200 miles away and are equipped with surface-to-air missiles and Phalanx CIWs. The Phalanx system uses radar-guided 20mm 6-barrel Gatling guns that fire 4,500 rounds per minute, similar to the cannons on American fighter jets like the F-16. A carrier strike group has enough equipment to intercept dozens of missiles from up to 200 miles away. However, it becomes vulnerable once it runs out of interceptors, which need to be stored and replaced after a battle. Some supplies can be refilled at sea, but missiles cannot be refilled at sea. They have to be refueled at a port. The Pentagon calls this a depth of magazine issue, meaning enemies could take advantage by overwhelming the defenses with lots of attacks. The Pentagon believes the best way to defend against swarming drones is with lasers. Unlike the lasers in Star Wars, real laser beams don't explode on impact, but instead produce intense heat. At lower power, they can mess up a drone's sensors, and at higher power, they can burn through it. Essentially, lasers turn energy into ammo. With nuclear reactors like those on the USS Ford, lasers could potentially fire thousands or even tens of thousands of times to stop incoming attacks. Because laser beams travel at the speed of light, they can follow and target fast-moving weapons, like China's hypersonic DF-ZF, better than traditional missiles. Gunners wouldn't need to predict where the target will be like they do now. Lasers are also much cheaper. The Congressional Research Service estimates that firing a high-powered laser costs between $1 and $10, much less than the millions it costs for defensive missiles. In 2014, the Navy installed the first laser on a ship for sea trials. Mounted forward on the deck of the amphibious transport ship USS Ponce, the 33-kilowatt SEQ-3 laser weapon system had a short, round, white-painted firing tube with two smaller tubes for sensors resting on its shoulders. To an untrained eye, it looked like an amateur astronomer's telescope. But even this early, low-power version delivered impressive firepower. A second, more powerful laser began testing in 2019. In August 2022, the Navy installed its first permanent laser on a destroyer, the Arleigh Burke-class Preble. The weapon, developed by Lockheed Martin, has a 60-kilowatt output and is integrated with the ship's advanced Aegis radar and weapons control system. The Navy calls it Helios, or high-energy laser with integrated optical dazzler and surveillance system. Later versions could be even more powerful. The Navy received its first high-energy laser system, called Helios, from Lockheed Martin in the third quarter of fiscal year 2022, and it is currently being installed on an Arleigh Burke-class destroyer that is getting upgrades, according to a company spokesperson. Rick Cordero, a vice president at Lockheed Martin, said that Helios improves the ship's ability to defend against future threats and provides extra protection for sailors. He emphasized that the system is designed to meet the Navy's specific needs and can be upgraded over time. Helios is part of the Navy's larger plan to increase its use of laser weapons. The Navy requested about $35 million for this group of systems in its 2023 budget, and the first system is expected to be used at sea that year. The weapon system helps fill gaps in defending against surface threats and surveillance, and can destroy drones and small attack boats. This technology is a big improvement over current systems, such as surface-to-air missiles and Gatling guns, which need ammunition and are expensive to use against cheap drones, according to an August report from the Congressional Research Service. Lockheed Martin thinks the weapon could eventually reach 150 kilowatts, but even at that level, it will be most useful against drones and small boats. To stop a wave of cruise missiles or a hypersonic weapon moving at speeds of Mach 5 or faster, the Navy will need a much more powerful laser. The Navy estimates that at least a 300 kilowatts laser is needed to defeat cruise missiles. This is because these missiles, besides being large and fast, have heat-resistant nose cones made from materials like pyrolytic graphite or ceramics, designed to handle the extreme heat of supersonic flight, which can go over 1,000 degrees Fahrenheit. Lasers will need to burn through these tough materials quickly. They also must be strong enough to overcome atmospheric interference and accurately hit a missile moving at 1 mile per second to destroy it. A new solution may be coming soon. The Navy plans to test a 300 kilowatts laser called HELCAP, or High Energy Laser Counter ASCM program, later this year. A 2020 photo behind Admiral Michael Gilday suggests that HELCAP will be based on the Navy's current Odin system, which is already on some destroyers. If the test is successful, HELCAP would be the Navy's first laser able to shoot down incoming anti-ship cruise missiles. However, even HELCAP won't be powerful enough to stop hypersonic missiles traveling up to Mach 10. These missiles can handle temperatures over 1,700 degrees Fahrenheit. The Pentagon estimates it might take a 1 megawatt laser, over 3 times stronger than HELCAP, to take them down. Luckily, megawatt-class lasers could be coming soon. The Navy gave Northrop Grumman a contract to develop such a laser, and in July 2022, the company finished a design for a high-energy laser that combines several beams into one. Northrop will first build a 300 kilowatt prototype, but the technology could eventually reach 1 megawatt. For the Pentagon, this technology is urgently needed, as billions are invested in aircraft carriers. With China's anti-ship weapons getting better fast, ships like the Ford are more vulnerable than they've been in decades. The future of the U.S. Navy might depend on stopping a single hypersonic missile, but the Navy hopes its new laser systems will be able to destroy these missiles at a much lower cost. The United Kingdom is also working on a laser system known as the Dragonfire. It was first shown to the public in 2007 at the Defence and Security Equipment International Conference in London. It is being developed by UK Dragonfire, a group made up of MBDA UK, Leonardo UK, Q, and the Defence Science and Technology Laboratory. A production version is expected to be used on Royal Navy ships by 2027. Dragonfire uses advanced technology developed in the UK to create a powerful laser beam with better performance, faster reaction times, and longer range. It uses many glass fibers, but the full details are secret. The laser system includes a camera and a weaker laser for tracking, all mounted on a rotating platform. The laser has about 50 kilowatts power and is meant to protect land and sea targets from missiles and mortar attacks. It might be powered by a new flywheel energy storage system being developed by the UK and the US. The exact range of the laser is classified, but each shot costs just €50. The UK plans to use these high-energy lasers on future Navy ships, Army vehicles, and Air Force fighter jets, including the BAE Systems Tempest, and will test them on a Type 23 frigate and a Wolfhound vehicle.
For decades, Lockheed Martin has pushed the boundaries of aviation to unimaginable heights. Working in the shadows, its Skunk Works division has pioneered aircraft so advanced, so lethal, and so secretive that their existence is known only to an elite few. Now, Lockheed Martin is poised to shock the world once more with its latest creation, an aircraft so fast it outpaces even lightning itself. Building on the legacy of past marvels like the SR-71 Blackbird, this new creation represents a quantum leap forward, incorporating bleeding-edge improvements in propulsion, thermal management, and stealth capabilities, begging the question: just how fast and how far has Lockheed Martin pushed the boundaries of hypersonic technology this time? Join us as we unveil the US-revealed top-secret hypersonic aircraft reaching Mach 10. Years after the retirement of the SR-71, there was a notable gap in surveillance coverage between satellites, crewed aircraft, and unmanned aerial vehicles used for intelligence, surveillance, reconnaissance, and strike missions. This lapse gave rise to anti-satellite weapons, anti-access/area denial strategies, and counter-stealth technologies. To address this, USAF agreed on a high-speed aircraft that could effectively enter protected airspace, gather intelligence, and easily strike down a target. Emphasis on its speed is a huge upgrade on stealth as seen in fifth-generation jet fighter programs and anticipated drone advancements. In 2007, there were talks about a new plane to replace the Blackbird, a really fast one. The US Air Force wanted Lockheed to make a plane that could go over Mach 6, which is more than 4,600 miles per hour, and fly across the country at a high altitude. They hoped to show it off in 2020, but that seemed too hopeful. Then, in 2013, the SR-72 was back in the news. Aviation Week and Space Technology got some secret info from the Skunk Works team at Lockheed. People got so interested that the servers crashed, not just from public interest but also from cyber attacks. The Skunk Works team said they wanted to make a plane that could do intelligence and surveillance work exceptionally well. It would fly at Mach 6, going high and fast into enemy territory. This would make it hard for other planes to catch or outsmart it, something drones couldn't do. The SR-72 could also hit targets before they even knew it was there, or could hide from fast spy planes. Going back a bit, Lockheed worked on a project from 2003 to 2006 for DARPA, creating a super-fast experimental vehicle called HTV-2. It could fly at Mach 20, testing technology that could let the US reach any target in the world in just 1 hour. This idea got bigger with the Prompt Global Strike Plan. Lockheed worked hard on the HTV-2, making it from strong materials so important parts wouldn't break, as they were so close to the surface. They didn't use regular steel because it would melt at high temperatures. The plan was to make a new version, the HTV-3X or Black Swift, by 2025. It would be a reusable superfast drone taking off from a normal runway. It could carry about 12,000 pounds of stuff and hit targets far away in less than 2 hours. However, after tests in 2010 and 2011, DARPA canceled the project because they had enough data. Even though the HTV-3X was canceled in 2008, they kept working on the HTV-2 until 2014, learning from the technology to make better tools and methods for designing superfast shells. Now, in 2013, Skunk Works shared a bit of their big plan with Aviation Week. They worked with Aerojet Rocketdyne for more than 7 years to make a way to connect a finished hypersonic engine with a scramjet to make a plane go from fast to undoubtedly fast, like Mach 6. They used the HTV-3X idea, but improved it, solving a key problem: the high-speed gas turbine engine. The Skunk Works team had a tough job: design an engine for planes that can fly slowly, go fast, and even super fast. It's like making a Swiss Army knife for different parts of the flight. In 2017, a Lockheed Martin executive talked about how they've made good progress in super-fast flight technology. They, along with DARPA and others, are working to bring new abilities to U.S. fighter planes and future projects. The details are secret, but they say the key to the SR-72's development is combining different types of engines and technologies for super-fast flight. The U.S. is working on more than a dozen super-fast flight projects. The SR-72 is linked to Mayhem, a secret Air Force program testing new jet engines. The special thing about these engines is that they can work like regular ones, allowing the plane to land and be used multiple times. This could be a big deal for defense and air travel, according to experts. No country has put a scramjet, a type of superfast engine, into a rocket or plane yet, but the U.S. is trying hard. In 2021, Northrop Grumman successfully tested a scramjet in the DARPA Hawk program. In 2022, Lockheed Martin also had success testing superfast technology. The Mayhem project is like a bigger version of the Hawk, but they're still figuring out how to use a regular jet engine without making the plane too heavy or blocking the superfast engine. The U.S. is leading in developing invisible technology, keeping an eye on other countries and trying to make systems that can detect it. The Mayhem project and other superfast planes are not focusing on being invisible. Instead, they want to fly super fast. This speed allows them to enter enemy areas, gather data, hit targets, and then quickly fly away. Another important part of these super-fast planes is where they put their weapons. Also, the surfaces of the planes need to resist extreme temperatures because they go at speeds of Mach 5 to 6. Not just the materials, but also the electronics must work at high speeds during the entire flight, keeping stable connections for precise maneuvers and dealing with defense systems. One challenge is making an engine that works well for planes like the SR-72. Another issue is the cost. Hypersonic missiles could be very expensive, estimated to be between $90 to $110 million, while a modern stealth fighter costs around $80 million. This is a lot more than the old Blackbird, which cost only $23 million in the 1960s. The SR-72 could be different. The former CEO of Lockheed thinks it might be similar in size to the F-22 Raptor and cost less than $1 billion. While this isn't confirmed, it's worth noting that the futuristic B-21 Raider bomber is estimated to cost $700 million per unit. People got excited about the SR-72 again because of the Top Gun movie sequel in 2022. It featured a super-fast plane called Dark Star, similar to what the Skunk Works division is working on. Information about this event appeared on Lockheed Martin's official website later on. What makes the SR-72 better than the SR-71? The SR-71, also called the Blackbird, was made to fly fast at high speed, more than Mach 3. It had 2 people on board, a pilot in the front and a surveillance officer in the back. The plane was designed to be hard to see, painted dark blue to hide in the night sky, earning it the nickname Blackbird. The SR-71 used a mix of flying very high and very fast to avoid being caught. Its radar tricks and dark color made it tough for enemies to track. Even if someone shot a missile at it, the SR-71 could often fly faster or dodge out of the way. The plane's body was mostly built with titanium and special materials. Lockheed, the company that made it, faced challenges because titanium is expensive and can corrode. Flying at high temperatures needed special designs, like wing sections that could expand without breaking. The body panels were fitted loosely on the ground, but fit together properly when the plane heated up in the air. The front window of the cockpit was made of quartz and connected to a titanium frame. The plane had fuel leaks on the ground because of heating, causing some trouble for the ground crew. Red lines on the wings showed where people shouldn't step. The SR-71's tires, filled with nitrogen and aluminium, cost $2,300 each and needed changing after about 20 flights. The plane landed fast and used a parachute to slow down and reduce wear on brakes and tires. Despite its challenging design, no SR-71 was ever shot down. Getting enough titanium was tough because the US needed more. The Skunk Works team had to find it from other places, including the Soviet Union. They got the titanium by using third world countries and tricky operations. The SR-71, mostly made of titanium, wanted to be hard for radar to see. Its shape and materials were made for this. The plane had special features like sharp edges and special materials on its skin to absorb radar signals. They also added things to the fuel to make the exhaust less visible. However, Soviet radar tech improved faster than the stealth measures. Sharp edges called chines were added for stealth. They weren't part of the original design, but were found to help the plane fly better. They also reduced landing speeds and made the plane more stable at high speeds. The air inlets on the SR-71 were important for fast flights. They let the plane go faster than Mach 3.2, which was its most efficient speed. The inlets had a part called a spike at the front that moved as the plane went faster. This helped manage airflow, making sure the plane could fly efficiently at high speeds. In the early flights, the computers had trouble controlling the spike's position, causing problems. Engineers fixed this by restarting the inlets and later added an electronic system to automatically fix the issue. NASA also found that the Chinese affected engine efficiency, leading to more improvements. In 1980, they replaced the old control system with a new digital one called DAFIX, which reduced problems with the inlets and improved overall performance. The SR-71 had two strong engines called Pratt and Whitney J58, producing 32,500 pounds of thrust when not moving. These engines worked best when the plane cruised at its usual speed of around Mach 3.2. When the plane took off, 26% of the thrust came from a part called the afterburner, which boosts engine power. The afterburner gave all the thrust at around Mach 3 as the plane sped up. First, air went through compression and heating to see how the engines worked. Some of the compressed air went to the afterburner, while the rest mixed with fuel in the combustion chamber. After passing through the turbine, the exhaust and some air from the compressor entered the afterburner. At Mach 3, the temperature rise from compression reduced the fuel flow allowed because the turbine temperature limit stayed the same. The rotating machinery in the engine became less powerful, but it was enough to keep the air flowing. The high-speed thrust now came from the afterburner's temperature rise. The plane's top speed was limited by the air temperature entering the engine, which couldn't go above 800 degrees Fahrenheit. At first, the SR-71 used external engines to start, but later a quieter system was developed. The SR-71 had different fuel options, but it mainly used JP7, which was hard to ignite. A substance called triethylborane was used to start the engines, Creating high temperatures needed to ignite JP-7. It produced a green flame during ignition. During takeoff, the SR-71 carried only partial fuel to reduce stress on brakes and tires. It quickly reached high speeds, using 1/3 of its fuel. Some thought the plane refueled right after takeoff due to fuel leakage, but it was needed for maximum speeds, which required aerial refueling. In-flight refueling was necessary for long missions, and special tankers were used. The plane used a navigation system that tracked stars through a window, correcting errors with celestial observations. The system was accurate enough to limit drift to 1,000 feet at Mach 3, according to a former pilot. The SR-71 had many tools and systems for its missions. It had cameras, radar, and electronic intelligence systems. The cameras could take pictures from different parts of the plane, and the radar systems were later upgraded with better technology. The plane also had countermeasure systems to protect against threats. These could jam signals and confuse enemy systems. The crew wore special suits to handle high altitudes and temperatures during flights. They couldn't use regular masks, so pressurized suits were made to provide enough oxygen. The cockpit had a cooling system to handle the extreme heat during high-speed flights. The crew also had a way to get food and drinks during long missions, using containers with straws that they could guide into their helmets. Overall, the SR-71 had various technologies to carry out its missions successfully, but it was retired in 1989, and some thought it was because of its cost and the belief that other reconnaissance methods were improving. The Air Force told Congress this. However, there were debates about whether the decision was more about politics within the Pentagon than the actual need for the aircraft. Some argued that the SR-71 had unique intelligence capabilities not provided by alternatives like satellites, U-2S, and UAVs. The Air Force leaders at the time believed the SR-71 was no longer essential, and there were efforts to convince Congress and the military services of its redundancy. Despite this, some argued that these claims were more of a sales pitch than a fact. The Air Force might have seen the SR-71 as a bargaining tool to protect other important projects. The leaders in charge didn't see the intelligence provided by the SR-71 program as very valuable for the Air Force, but believed it was more important for other agencies. There was a misunderstanding about aerial surveillance, and a lack of knowledge about the SR-71 led to efforts to discredit it, with promises of a replacement being developed. Dick Cheney mentioned to the Senate that the SR-71 cost $85,000 per hour to operate, but opponents estimated its support cost much higher than it was. The SR-71 was better than the U-2 in terms of range, speed, and survivability, but it lacked a data link that the U-2 had. This meant the SR-71's data couldn't be used in real time and had to wait until it returned to base. This limitation became a reason to shut down the program. Some argued that the lack of upgrades made it seem outdated, favoring those pushing for other programs. Attempts to add a data link were hindered by factions in the Pentagon and Congress that wanted to end the program. Even though Congress allocated funds in 1988 to keep 6 SR-71s operational, the Air Force didn't spend the money. The decision to retire the SR-71 from active duty came in 1989, with the last missions flown in October of that year. General Schwarzkopf later found during Operation Desert Storm that the quick reconnaissance the SR-71 could have provided was not available. The main operational capabilities of the SR-71 program ended in October 1989, and the squadron closed in mid-1990 with the aircraft distributed to display locations or kept in reserve storage. Concerns about political situations in the Middle East and North Korea led the U.S. Congress to reconsider the SR-71 in 1993. Rear Admiral Thomas F. Hall explained that the SR-71 was retired because it couldn't meet the fast-paced needs of the modern battlefield. They believed using technology to get data in real time would better suit the tactical commander's unique requirements. They were also exploring other ways to do the SR-71's job. Mackey informed the committee that they used U-2S, RC-135S, and other assets to gather information in some areas. Senator Robert Byrd and others were unhappy that a successor to the SR-71 hadn't been developed, considering it as good as the SR-71. They argued that creating an aircraft with the same capabilities as the SR-71 would be impossible in a time of limited military budgets. Congress was disappointed with the lack of a suitable replacement for the SR-71, which influenced decisions about funding imaging sensors on the U-2. They added $100 million to the budget to bring 3 SR-71S back into service, but later cut it to $72.5 million. The Skunk Works, responsible for the aircraft, managed to get it back into service under budget at $72 million. Retired USAF Colonel J. Murphy led Lockheed's reactivation plans, with retired USAF Colonels Don Emmons and Barry McKean working on the logistics and support structure. Active USAF pilots and reconnaissance systems officers who had experience with the SR-71 were asked to volunteer to fly the reactivated planes. The 9th Reconnaissance Wing at Beale Air Force Base was in charge of the aircraft, which operated out of a renovated hangar at Edwards Air Force Base. Modifications allowed near real-time transmission of the advanced synthetic aperture radar's imagery to ground sites. Bringing back the SR-71 faced many challenges. The Air Force didn't plan for it in their budget, and developers of unmanned aerial vehicles were worried their projects might suffer if money went to the SR-71SS. Congress had to approve funds yearly, making it hard to plan for the SR-71 in the long term. In 1996, the Air Force said they needed more specific funding and tried to stop the program. Congress approved the funds, but in 1997, President Bill Clinton tried to cancel the $39 million allocated for the SR-71 using the line item veto. In 1998, the U.S. Supreme Court said the line item veto was unconstitutional. The SR-71's fate remained uncertain until September 1998, when the Air Force asked for the funds to be used elsewhere, and they permanently retired the SR-71 in 1998. NASA used the last 2 flying Blackbirds until 1999. All other Blackbirds are now in museums, except for 2 SR-71S and a few D-21 drones kept by the NASA Dryden Flight Research Center. For a while, no plane could do what the SR-71 could. Now, there's a new one called the SR-72. As countries like Russia and China get stronger, the U.S. needs an unstoppable aircraft like the Blackbird, and that's why we have the SR-72.
For decades, the U.S. military has been at the forefront of aerospace innovation, constantly pushing the boundaries of what we thought was possible. With advanced technology evolving at breakneck speed, whispers of revolutionary aircraft have sparked intrigue and speculation. What if the military has been secretly developing a fighter jet so advanced that it defies the very laws of physics? What groundbreaking capabilities could this aircraft possess? Join us on an exciting adventure as we uncover the mysteries behind some of the U.S. military's top-secret fighter jets. The invention of machines that allowed humans to fly changed the world forever. When the Wright brothers made their historic flight in 1903, it was an astonishing achievement, but no one could have predicted just how far-reaching its impact would be. In less than a decade, aircraft evolved from a novel curiosity to a critical tool in warfare, sparking one of the most intense periods of innovation in history. By the time World War I broke out in 1914, military strategists quickly recognized the value of flight for reconnaissance and surveillance. The first aircraft were used primarily to observe enemy movements and gather intelligence, but it wasn't long before they were fitted with machine guns and bombs, turning them into offensive weapons. The introduction of fighter planes led to aerial dogfights, and the race to build faster, more agile aircraft had begun. Nations saw the potential of air superiority as a decisive factor in winning battles and ultimately wars. Aircraft designers were constantly innovating, trying to build planes that could outmaneuver and outgun the enemy. Pilots became aces, hailed as heroes, while engineers pushed the boundaries of aviation technology. The conflict marked the first time in history that aerial combat played a significant role in warfare, and it was clear that the future of military strategy would involve control of the skies. The interwar years saw rapid advancements in aviation technology. Airplanes became faster, more reliable, and capable of flying longer distances. Nations invested heavily in developing bombers and fighters, knowing that the next major conflict would see even more intense aerial combat. By the time World War II erupted in 1939, aircraft had become central to military operations. The skies over Europe and the Pacific became battlefields, with bombers like the B-17 Flying Fortress and fighters like the Spitfire and Messerschmitt battling for dominance. World War II transformed aviation. Bombing campaigns devastated cities, and air superiority became a critical component of both offense and defense. The Battle of Britain, fought entirely in the air, was a pivotal moment, demonstrating the importance of defending a nation's skies. Aircraft carriers emerged as the backbone of naval strategy, allowing planes to extend their reach across oceans. The war pushed aviation technology to new heights, with jet engines making their debut late in the conflict, signaling the next revolution in flight. The relentless pursuit of faster, higher, and more powerful aircraft continued throughout the war. Engineers sought to build planes that could evade detection, fly at incredible altitudes, and carry heavier payloads. The development of long-range bombers, like the B-29 Superfortress, allowed nations to strike deep into enemy territory, forever altering the nature of warfare. As World War II drew to a close, it was clear that aviation had become one of the most critical fields of technological innovation. The race to fly faster, higher, and more stealthily had only just begun, and the lessons learned from these early years of military aviation would lay the groundwork for the next great leaps in flight. During the Cold War, the race for aerial supremacy reached heights few could have imagined. In 1955, the U.S. government, led by the CIA, the Air Force, and defense contractor Lockheed Martin, chose a remote site in the Mojave Desert of southern Nevada for a highly classified project. Located about 120 miles northwest of Las Vegas, just off Nevada's State Highway 375, known as the Extraterrestrial Highway, an unmarked dirt road leads to Groom Lake, or Homey Airport, as it's called on civilian aviation maps. To the casual observer, it's just a vast, empty stretch of desert. But for those in the know, that dirt road leads to one of the most secretive military installations in the world. A base that has gone by many names: Paradise Ranch, Watertown, Dreamland Resort, The Box, but is most famously known as Area 51. The establishment of Area 51 was driven by the pressing need for advanced aircraft technology during the Cold War. In the years leading up to this, the area around Groom Lake had been used for silver and lead mining. But by the mid-1950s, the site had caught the attention of the U.S. government, largely due to its remote location and vast, flat expanse. The Atomic Energy Commission soon added it to the Nevada test site map, labeling it simply as Area 51. What would happen there in the following decades would change the course of aviation history. One of the earliest and most critical projects at Area 51 was the development of the U-2 spy plane. The U-2 was an unprecedented aircraft, designed to fly at altitudes higher than any other plane in existence at the time. Within 8 months of selecting the Groom Lake site, engineers had successfully developed the U-2, which could soar to 70,000 feet, well above the range of Soviet radar and anti-aircraft missiles. This high-altitude capability allowed U.S. pilots to fly reconnaissance missions deep into Soviet airspace. Gathering vital intelligence without being detected, at least initially, the U-2 program marked a new era in surveillance, giving the U.S. a critical edge during the early years of the Cold War. However, the U-2's advantage didn't last forever. In 1960, a U-2 piloted by Francis Gary Powers was shot down by a Soviet missile, exposing the U.S.'s surveillance operations and heightening tensions between the superpowers. It became clear that a new aircraft was needed, one that could fly even higher and faster, minimizing the chances of detection or interception. The CIA and Lockheed Martin began working on the next generation of spy planes, the A-12, a supersonic aircraft made from titanium, a material chosen for its ability to withstand the extreme heat generated by flying at high speeds. The development of the A-12 was a direct response to the vulnerabilities exposed by the U-2 incident. Lockheed's Skunk Works division, which had also developed the U-2, was tasked with creating a plane that could fly faster and higher than anything that had come before. Lockheed's team went through 12 design iterations before finalizing the A-12. In January 1960, the CIA ordered 12 A-12 aircraft, and by February 1962, the first A-12 was transported to Groom Lake for testing. The plane made its official first flight on April 30, 1962, though its initial flight days earlier had been plagued by technical issues. The A-12 was a marvel of engineering, capable of flying at speeds of over 2,200 miles per hour, more than 3 times the speed of sound, and reaching altitudes of 90,000 feet. From such heights, the A-12's advanced cameras could capture images of objects as small as 1 foot in length on the ground below. The plane was virtually undetectable by radar, making it an ideal tool for intelligence gathering during a time when U.S.-Soviet relations were at their most strained. Despite the A-12's impressive capabilities, its role as a high-altitude, high-speed spy plane was soon overshadowed by political and practical considerations. After the U-2 incident, the U.S. had signed an agreement with the Soviet Union not to fly manned reconnaissance missions over each other's territory, rendering the A-12's primary mission obsolete before it had even fully come into service. The Air Force, realizing this limitation, began to push for a new version of the aircraft that could perform similar tasks without violating the agreement. This led to the development of the SR-71 Blackbird, a slightly larger, more advanced version of the A-12, designed to gather peripheral intelligence without directly entering enemy airspace. In June 1962, the SR-71 project received approval from the Air Force, and its development proceeded rapidly. By 1964, the first SR-71 was delivered to the Groom Lake test facility, and in 1966, the Air Force decided to phase out the A-12 program altogether, citing the high cost of maintaining 2 similar aircraft programs simultaneously. The last A-12 was delivered in 1964, and in 1967, the A-12 and SR-71 were put to the test in a head-to-head reconnaissance fly-off. While the SR-71 was ultimately chosen to continue in service, many still believe that the A-12 was the superior aircraft in terms of performance. The A-12 did see combat during its brief operational history. In May 1967, A-12S were deployed to Kadena Air Base in Okinawa, Japan, where they were used in reconnaissance missions over North Vietnam. The A-12's first combat mission, flown in May 1967, lasted just over 3 hours, during which the aircraft gathered valuable intelligence on North Vietnamese defenses. However, by 1968, the A-12 program was officially terminated, and the remaining planes were put into storage. The SR-71 took over the role of America's premier spy plane, flying its first operational mission in March 1968. Although the A-12's operational life was short, its legacy is long-lasting. The aircraft represented the pinnacle of Cold War aviation technology and set the stage for the development of future high-speed reconnaissance planes. By 1968, Lockheed was ordered to destroy all tooling used to create the Blackbirds, and the remaining A-12S were mothballed until they were eventually sent to museums, where they stand as a testament to a time when the race for aerial supremacy was a matter of national security. On July 28, 1976, the SR-71 Blackbird set a world speed record that still stands today. Pilots flew the aircraft at an incredible speed of Mach 3.3, which translates to 2,193 miles per hour. To put that into perspective, it was faster than a speeding rifle bullet, covering 400 feet every second. Designed for reconnaissance, the SR-71 was a marvel of Cold War engineering, built to fly higher and faster than any aircraft of its time, avoiding enemy missiles with pure speed. The Blackbird's titanium construction allowed it to withstand the extreme temperatures generated at such high velocities. During its operational years, it was virtually untouchable by adversaries, outpacing missile threats while gathering vital intelligence. In 1990, after a career spanning more than 2 decades, the SR-71 was retired, leaving behind an unmatched legacy in aviation history. Despite newer advancements in aviation, no aircraft has surpassed its speed, and it remains an iconic symbol of American ingenuity. Its contribution to reconnaissance and its technological feats have secured its place in the annals of aviation greatness. For decades, the aviation community has been buzzing with rumors of secret military projects, leading to countless theories about top-secret aircraft. One of the most intriguing among these is the TR-3B Black Manta, a mysterious triangular aircraft that has captivated the imaginations of UFO enthusiasts and conspiracy theorists. Despite the lack of official confirmation, the TR-3B has become a legendary figure in the world of secretive reconnaissance aircraft. While some dismiss it as science fiction, others believe it could be one of the most advanced aerial vehicles ever created. In many ways, its legend rivals even that of the SR-71 Blackbird, which is renowned for its speed and altitude capabilities. But could it be that the SR-71 Blackbird owed its success, or perhaps its cover story, to an aircraft like the TR-3B? Let's dive into the mystery surrounding the TR-3B, explore sightings of triangular UFOs, and try to determine whether this aircraft is grounded more in fact or fiction. The TR-3B is rumored to have been developed under a black project. Black projects are top-secret military developments, often so secret that the government may not even acknowledge their existence. Many have speculated that the TR-3B uses technology far beyond anything officially known, with claims that it incorporates anti-gravity propulsion or other cutting-edge, physics-defying capabilities. Such ideas have fueled speculation for years, giving rise to stories that blur the line between military aviation and science fiction. Rumors about the TR-3B began swirling as early as the 1980s, and the aircraft were often reported to be hovering or moving slowly at low altitudes, completely silent. It was believed to be a product of top-secret military engineering, potentially incorporating advanced, even alien technology. Some witnesses described seeing multicolored lights on the underside of the objects. One of the most famous early sightings occurred over the Hudson River in New York, where several hundred people reported seeing a V-shaped object flying slowly overhead. The report sparked widespread interest, especially since some of the objects seemed to be tracked directly to local airports. Around the same time, the mysterious triangles were reported in Europe as well. In the fall of 1989, what would become known as the Belgian wave began, with sightings of triangular UFOs peaking in November of that year. In Belgium, at least 30 groups of witnesses, including police officers, reported seeing a large, flat triangular object with bright red lights beneath it. According to many, the most astonishing thing was the complete absence of sound as the object moved silently across the sky. While skeptics suggested that helicopters could explain these sightings, many found it hard to reconcile the lack of noise with the usual sounds associated with helicopters, leaving the mystery unresolved. Descriptions of the craft bear a striking resemblance to the silhouette of the legendary B-2 Spirit stealth bomber, but with one critical difference. The TR-3B reportedly features a strange spar in the center and lights around its edges. In 1991, journalists from Aviation Week and Popular Mechanics connected the dots between this mysterious craft and the development team behind the B-2 Spirit bomber. They speculated that two versions of the aircraft existed, the TR-3A and the larger TR-3B. The TR-3A, they claimed, was about 42 feet long, 14 feet tall, and had a wingspan of 60 to 65 feet. But the TR-3B was said to be significantly larger, with an astonishing wingspan between 600 and 800 feet, making it 4 times larger than the Boeing B-52 Stratofortress. What made the TR-3B especially intriguing was its rumored coating, a radio-absorbing polymer capable of altering not only its reflectivity, but also its color. This material, combined with the craft's advanced avionics, allowed it to appear on enemy radar as a much smaller object, possibly no bigger than a modern photography drone. It was designed for reconnaissance and stealth, but its true capabilities remain shrouded in mystery. One of the most fascinating aspects of the TR-3B story is its alleged use of alien technology. Some sources suggest that the American military had reverse-engineered technology recovered from a crashed extraterrestrial spacecraft. This reverse engineering effort reportedly led to the development of advanced black projects, including the TR-3A and TR-3B. The TR-3B's propulsion system, in particular, has been the subject of wild speculation. Unlike the TR-3A, which was rumored to use a conventional turbojet engine, The TR-3B was said to be equipped with an anti-gravity engine. This was no ordinary engine. According to the rumors, it involved a ring accelerator or a magnetic field disruptor located at the core of the aircraft. The core supposedly contained mercury-based plasma, kept under immense pressure of 250,000 atmospheres at a temperature of 150 degrees Kelvin. The plasma was then accelerated to 50,000 revolutions per minute, generating a superconducting field that allowed the craft to create an anti-gravity bubble around itself. This anti-gravity field, in turn, reduced the craft's weight by a staggering 90%, enabling it to achieve extraordinary speeds, potentially exceeding Mach 9 or 9 times the speed of sound. Such speeds would make the TR-3B one of the fastest aircraft ever built, if it indeed exists. To many, these descriptions of the TR-3B sound like pure science fiction, reminiscent of the golden age of speculative novels. After all, the concept of an anti-gravity engine seems to defy the known laws of physics. Yet the persistence of sightings, both in Illinois and Texas, and the wealth of circumstantial evidence have fueled belief in the possibility that such a craft exists. Could this be an advanced military reconnaissance aircraft? Or is it something more? The mysterious world of advanced military technology often blurs the lines between science fiction and reality. This is particularly evident in the discussions surrounding the so-called Black Manta project and the possible existence of technologies so groundbreaking that they challenge our understanding of physics and propulsion systems. A key piece of evidence for these secretive developments comes from the U.S. Air Force's work on next-generation propulsion systems, hinted at through patents that may reveal glimpses of their future capabilities. Of course, under the Invention Secrecy Act of 1951, the military has the right to keep many of its patents classified to protect national security. Yet some patents have been made public, and they spark intrigue. One of the most famous patents is from Lockheed Martin, which filed for a containerized cold fusion reactor. This technology, small enough to fit inside an aircraft like the F-16, could revolutionize the world of energy and propulsion. Some observers have even described it as having an extraterrestrial nature due to its almost unthinkable potential. But that's just the tip of the iceberg when it comes to mysterious military technology. Salvatore Cesar Pais, an American engineer with a background in aerospace technology, has become a notable figure in the discussion about these futuristic inventions. His research, sponsored by NASA and conducted while working for Northrop Grumman, led him to file multiple patents for devices that sound straight out of a sci-fi novel. His most famous patents include a plasma compression fusion device, which was described by popular mechanics as a compact fusion reactor, and an electromagnetic field generator aimed at deflecting asteroids. But perhaps his most intriguing patent is for a device that purportedly reduces the inertia of a mass, a claim that, if true, could rewrite the rules of physics as we know them. The inertia reduction device, which is said to engineer the fabric of reality, sounds otherworldly, especially when connected to the mysterious TR-3B. The TR-3B, allegedly capable of reducing its mass by 90% using a mercury plasma-based propulsion system, would be unlike any aircraft publicly known. Some reports claim it was even used during the Gulf War for reconnaissance and laser targeting missions, providing support to F-117 Nighthawk bombers. However, the truth behind the TR-3B remains elusive. Interestingly, while the concepts in these patents sound far-fetched, Pais was awarded a relatively modest $58,000 to test his theories between 2016 and 2019. Ultimately, no working prototypes were ever produced, and the scientific community remains highly skeptical of his claims. Many physicists have dismissed his patents as lacking any real scientific basis, stating that the underlying principles do not align with established physics. What adds to the intrigue is the decision to publicly file patents for such technologies in the first place. If these devices truly had the potential to reshape our reality, why would the military allow any details to be disclosed to the public, even through a patent filing? Some argue that it may be a tactic to confuse potential adversaries by making them question what technology the U.S. military actually possesses. Others speculate that the patents are little more than distractions, designed to lead curious minds down dead-end paths, while the real advancements remain hidden behind the walls of facilities like Area 51. It's no secret that the military has been working on advanced stealth technologies, including adaptive turbofan engines for the next generation of stealth fighters. The U.S. Air Force has reportedly allocated over $5 billion to the development of these new engines, which will power fighters capable of evading radar detection and performing at unprecedented levels. But could there be more to these developments than meets the eye? Some believe that these public efforts to improve fighter jet engines are merely a cover for the real game changer, propulsion systems that defy our current understanding of physics. The secrecy surrounding projects like TR-3B only fuels speculation. The idea that somewhere hidden deep within secret military facilities, there are prototypes of futuristic devices collecting dust while we remain in the dark is a thrilling thought. After all, history has shown us that the military often develops cutting-edge technologies for years, if not decades, before they become known to the public. Could the TR-3B project, with its alleged use of alien technologies, be part of this hidden arsenal? On one hand, the patents of Salvatore Cesar Pais and Lockheed Martin point to revolutionary possibilities in propulsion and energy systems. On the other hand, the skepticism of the scientific community and the lack of public prototypes make it difficult to separate fact from fiction. The U.S. military's history of secrecy only adds to the mystery. In the early 2000s, reports of mysterious sightings in Illinois began to intrigue locals, fueling further rumors of the elusive TR-3B. One of the most mysterious and widely reported events involved the appearance of a large, black, triangle-shaped object that hovered silently over several cities. This wasn't just a fleeting encounter either. The phenomenon spanned years and left many bewildered by what they saw. The Federal Aviation Administration, FAA, stepped in when these sightings first gained attention. In one particular case, the FAA claimed that people had confused the mysterious black triangle with a blimp from an American advertising company that was operating in the area. But this explanation didn't satisfy everyone, especially as the object was captured on camera multiple times. Its presence was so notable that it was featured in a Discovery Channel special and television series, and it even inspired some musical references. This was no ordinary sighting of an aircraft. There was something different about this triangular object that had people talking for years. From 2004 to 2006, residents of Tinley Park and Oak Forest, two suburban communities in Illinois, witnessed what many believe was the same black triangle. This time, the object was marked by 3 red lights that hovered around the perimeter of its triangular shape. These sightings were widely reported, and the eerie lights left a lasting impression on those who saw them. As people tried to make sense of what they were seeing, the mystery only deepened. In 2008, similar sightings occurred, but this time in Texas. Once again, people reported seeing triangle-shaped objects in the sky, often accompanied by lights. These events garnered national attention, and they were even mentioned in the 2023 Netflix documentary Encounters, which explored unexplained aerial phenomena across the United States. One thing became clear over the years. Whatever this object was, it was persistent, mysterious, and remarkably similar to descriptions of a secretive aircraft known as the TR-3B. As these sightings have shown, the truth is still out there, and the black triangle remains one of the most enduring mysteries of our skies. Today, the U.S. Air Force stands as the world's largest and most advanced, with an unmatched lead. While much of the supremacy is thanks to cutting-edge technology, the foundation was laid by the experimental aircraft tested at Area 51. These X-planes were the trailblazers, shaping the future of aviation by pushing the boundaries of possibility. The journey began with the Bell X-1 in 1946, developed by the Air Force and NECA, now NASA. The X-1 made history as the first aircraft to break the sound barrier in level flight. Since then, numerous X-planes have introduced groundbreaking technologies, super maneuverability, stealth, and hypersonic flight, to name a few. The SR-71 nearly reached hypersonic speeds, while the F-117 Nighthawk proved that ultra-stealth was achievable. The rumored TR-3B may represent the pinnacle of these advancements, embodying the ultimate X-plane and hinting at even more incredible possibilities for the future. Could the U.S. military really possess technologies that can manipulate the very fabric of reality? And if so, what does that mean for the future of aerospace engineering, defense, and even humanity's understanding of the universe? Let us know your opinion in the comments below.